Hello, everyone, and welcome to QuaNTA NXT 2024, Globant's premier global quality engineering conference, where we explore the latest trends, tools, and techniques in the world of testing and quality assurance. I'm Fahad Sheikh.
And I'm Shirley Francis.
And we are your hosts for today. We have an amazing lineup of speakers from the world of quality engineering. And before we begin, let's understand a little more about Globant and the next conferences. As you may be aware, Globant is a digitally native company that helps organizations reinvent themselves and unleash their potential. We are the place where innovation, design, and engineering meet scale. With over 29,000 professionals in over 33 countries and 5 continents, we believe we are the igniters of the digital revolution.
And you must be wondering, what are Globant's next conferences? So let me tell you about that. At Globant, we're driving thought leadership in different spheres of technology and innovation. With that objective, we've launched our homegrown Next conferences 7 years ago. While our Next conferences have a huge following in Asia Pacific and Latin America, the next logical step was to expand to a global level, which is what we're doing in 2024. Once again, welcome to Globant's QuaNTA NXT 2024. And don't forget, please post your questions in the chat box. We will now have a look at a little video.
All right, then, let's kickstart this iteration of QuaNTA NXT, and we have none other than our very own Shivraj to kickstart the conference. Shivraj, fondly known as Shiv, is the head of Globant's Asia Talent and Delivery Center. He focuses on the expansion of the transformational capacity at Globant in the EMEA and the Asia Pacific region. In his current role, Shiv focuses on creating and nurturing talent and making the organization ready to take up digital transformation challenges. He specializes in capacity management and business growth, organization building, delivery management, and quality analysis. Shiv has a rich and varied experience in working with niche software development setups that focus on leading-edge technologies as well as transformative journeys. Good evening, Shiv, and welcome to QuaNTA NXT.
Thank you very much, Fahad and Shirley. This is super exciting, I must say. I think a very warm welcome to everyone in the Americas, in Europe, in Asia Pacific. This has been an amazing journey so far. Starting 7 years ago in 2018, we had an idea. We had an idea of talking about what happens in quality next. That's how QuaNTA came into being. That was quality assurance and new technologies ahead. That was QuaNTA. And then we also started thinking, what and how will things change every single year? We got some amazing response from everyone the first year, and this is what told us that there is a huge hunger for a platform that can bring together people, especially who are specialized and experts at quality assurance. I think from there on, things have moved very, very rapidly. We've expanded across geographies, like Shirley mentioned, but more importantly, I think the topics have been more and more exciting as they've gone. This year, however, it's going to be very, very different. What we see happening in the industry is a tectonic shift in how software development will happen itself with the advent of AI, Gen AI, and we believe very strongly that this is going to change the fabric of how we are going to do development in the future days. This also means that this is going to have a big impact in quality assurance, be it manual test automation performance or any aspect of quality assurance. What we've seen with AI is a big challenge to the big definition of quality assurance itself. In the past, what we've seen with a lot of quality assurance engineers is the need for having specialized quality assurance engineers. Now, why did we never go to a stage where developers were the only one doing the testing? Why weren't developers always being able to find all the bugs that are necessary? This happened necessarily because we realize that there is a mindset change. A developer, when he's he or she is doing a unit testing, they're hoping that there are no bugs, right? Whereas when a tester is testing, they're hoping that they find every single bug that there is. This mindset change is what propelled us to really ensure that we have practices, we have theories which specialize in finding more and more bugs and going towards quality assurance. With AI, however, you have to realize that this is changing drastically. You will have AI libraries who are able to write test cases, who are able to write use cases, and who are able to test end to end. You might then ask, what is the value of being a quality assurance engineer? And that's, I think, something that we all need to ponder on. That's all something that we need to get onto this journey very, very quickly. At Globant, for example, we've been very, very, let's say, nimble in terms of moving ourselves very quickly towards AI-based testing through a lot of amazing tools like MagnifAI, and I think you'll hear about a lot of those in the future. But predominantly, what we are focusing on is our ability to use agentic systems to really provide value-based quality testing, right? I think from here on, I think I want to just rob a big, I would say, saying from Jensen Huang, who's the founder of NVIDIA. People keep asking, will AI take away our jobs? The answer is AI will not take away your jobs, but someone who uses AI better will definitely take away, right? So that's the critical aspect to remember. From here on, every single time we talk about quality assurance, it's not going to be whether we are spending X number of hours to test, if we have been able to find a certain outcome in a fixed cost contract. But what's going to be really important is, are we able to provide value, and are we able to provide business value as quality assurance folks? So for us, the definition of quality, for us, the definition of testing process itself is going to drastically change. Where at one point we used to think sprints for 2 weeks and sprints which were 2 and 1 week long, now we are thinking of sprints which could be 2 day long. When we had a startup which had about 200 people odd doing the startup, we have startups which have 4 and 5 people, which are delivering products code end to end. With this new reality, I think it's very important for us to start redefining again what quality means, what testing means, what a bug means, and what does it mean to be a test automation. Remember, folks, there was a time when we used to even challenge whether test automation will have more traction than quality assurance, which is pure manual. But then, for example, as of today, we have more population in test automation just within Globant than even manual QA. This is a bell of recognition. I think we have to recognize the fact that AI and Gen AI is here to stay. It is not only changing how applications are being built, smartly built, but at the same time, the whole software development lifecycle itself is changing. It's rapidly changing. We need to adapt to it. So my urge to all of you will be to keep a very open mind throughout all the conference, or throughout the whole conference today. Make it as interactive. I think wherever possible, post in your questions. It's very important that we make this very, very interactive. Again, I don't want to take up a lot of your time today because there's so much more amazing content coming after this. So I will just set this whole context by saying, folks, this is an amazing change we are going through. This is a generational change, and this is once in a while. So make the most out of it. A very warm welcome for all of you for QuaNTA 2024. And I hand it over back to Shirley and Fahad.
Thank you so much, Shiv, for that lovely kickstart to QuaNTA NXT. Now, let's dive into our first topic and explore how businesses can effectively gear up for the impact of AI. The speakers for this panel discussion are David Milette from Canada, Andrew Knight and Sebastian Arnaudo from the USA, and Anaga Pawar from India. David is a co-founder and chief technology evangelist at SUA Logic. With over 20 years of experience in software quality assurance, David now aims at assisting organizations achieve solid ROI out of their investment into automation solutions.
Andrew is the Senior Director of Product Management at Cycle Labs. Andrew calls himself the Automation Panda and is an advocate for software quality who loves to help others. Andrew speaks at international conferences, webinars, and workshops, and is the author of a software blog at automationpanda.com. He has created 4 courses for Test Automation University and has built test automation solutions from the ground up.
Sebastian is our Senior Technical Director at Globant. Sebastian coaches and leads teams in the implementation of agile testing practices, ensuring the product deliverables meet all the expected levels of quality, and contributes to the quality engineering studio at Globant by defining new practices or redefining existing ones.
And lastly, we have Anaga Pawar, the Vice President of Technology at Globant. Anaga leads large engineering teams from the product or project management inception to production release and has a proven track record in designing, developing, implementing, as well as supporting many end-tier and cloud-hosted applications. So without spending any more time, let's welcome these incredible speakers and dive right into the panel discussion.
All right. Hello, everyone. Good evening, good morning, and good afternoon. Thank you so much for connecting on this QuaNTA conference. So we have a very interesting topic to cover today. And as a part of the panel discussion and with the context set for it by Shiv, which says about how AI is going to be helping us and Gen AI is going to be helping us in doing overall quality testing for present and future. So the topic for the panel discussion is Gear Up for AI Impact on Business, Present and Future. We definitely need to take in a little more details from the expertise that we have from across the different software industries that we have over here. So they have been already introduced, and let me dive right into it and ask the first question to David and Andrew. So here's the first question, David. I hope it's a good morning for you. And David, here's the first question for you. With LLMs like GPT becoming integral part of our life, right? I mean, we're using it really every single day when I even have to type an email. Where do you see, or how can business create a culture that embraces AI and continuous learning? So yes, David, can you please give us more insights into that?
Yeah, I would say start from the top down, right? I mean, it's a change initiative that requires an organization to change the way they think and adapt to the way they're using tools. So the executive team from all the way from the top need to embrace the transformation, need to understand what it'll entail inside of the organization, have policies and practices around that are clear to the employees on how and where they want the technology to be used. And also, in parallel to that top-down approach, have a bottom-up approach, allowing users at different levels to have training access and access to informational sessions that will allow them to get better. And I'll leave some space for my colleague. I know we got a lot of questions, so I'll pass on the ball to my friend over here who can actually continue off of that.
Absolutely. Yeah, Andrew, thank you so much for that, David. Yeah, Andrew, what do you think? How can we start getting in more AI and AI generation learners over here?
Yeah, so I completely agree with David. I would also say, don't be afraid. Anytime there's a new technology, AI, automation, who knows what else, like CDs versus Betamax tapes or something. There are people who are very quick early adopters, and then there are laggards. I would say don't be the laggard and don't be afraid. Even if it's something new, just dive in and give it a try. I mean, it took me probably a month or two before I finally logged into ChatGPT the first time. And as soon as I use this, like, wow, this is actually really helpful, really cool. And another thing I would say is, particularly within a corporate environment, if you are in a leadership position, remove blockers from people using it. I know sometimes there might be corporate policies, firewalls, people in certain positions of power saying, don't do that, right? Try to unblock that, because bureaucracy can stall innovation.
Right. Absolutely. So, in fact, in my experience, also very well put together. In my experience, also a lot of times we also want to the early ones who adapt to these technology, right? I mean, the reward and the recognition system also helps, right? Giving them a visibility. Okay, these are the ones, and even showcasing the value that okay, after you start using these technologies, like you said, don't be afraid, see the value that it is adding, and go ahead, start using it, see how it is going to expand on your usage, and see you will experience it that this is giving a much more value than what even the tool is claiming about. So that definitely helps over there. Thank you so much for that. Moving on to our next question, which I'll again give it to Andrew and Sebastian. What factors should business consider when deciding to invest in AI technologies? And why in particular, I'll tell you why I'm more interested in understanding your viewpoints. Because though all companies are, investing in AI, like the big shots, the small ones, the startups, everyone, all of them. But at the end of the day, we see a lot of failures happening over there also, right? Like almost 50% of the projects are failing. So as a company, how would one think about investing in AI in particular? Yes, Andrew.
Sure. I think that companies need to look less at AI being the technology used and more on the value added by these projects, the features they delivered, and the usefulness that they provide. We don't want AI to just be this gimmicky buzzword we throw around. We don't necessarily need AI in everything. What we have to keep in mind is that AI is just another tool and another technique. And it empowers us to solve certain problems we weren't able to solve before, and certain problems we can solve more easily and readily. But some problems aren't necessarily the right domain for these kinds of techniques and technologies. And so we need to be wise about that. Just trying to throw AI at anything and everything, of course, 50% is going to fail, because right now we're in that early phase of, well, let's try it and see if it sticks.
Right. Exactly.
As we get smarter and wiser, we need to be intentional about when and where and how we use it, and make sure that we're actually getting something valuable for what we're investing in.
Perfect. Okay. Seba?
Yeah, I totally agree with what Andy said. Actually, there was a lot of saying of, hey, let's use AI just for the sake of using AI and throw it to everything, as Andy said. And that's not the best approach. That's why we are seeing a lot of projects failing, because we have not taken the time to analyze if AI was the right tool to solve the problem that we want to solve. Yeah. So I think there is a lot of analysis that needs to be done before deciding if AI is the right tool, because as Andy said, it's a tool that will help us solve the problem. If it is not the right tool, there might be other there, right? I think that is something that we need to put on the right perspective, trying to understand the business cases that we have and make sure that if we use AI, we are going to get the benefit from using it, right? Trying to measuring the benefits that we are going to get from using AI. As in any other project, what is the return of investment if I use AI to solve this particular problem, and how we are going to measure that, because we need to be able to pivot, as in any other approach, to the right tool if AI wasn't the solution for that problem at hand. I totally agree with that.
Right. And I think even perfectly put out, right, that whether we are using the right tool for solving the right problem. And that is something that everyone, all of us go ahead and, do it there. I think a little bit more details, like even if we have to look at the business value that the tool is getting in, right? I mean, is it really solving a business problem? Are we getting do we have the required technology? Do we have the required data for doing all of these? Though we may find, I mean, as a company, we may find that, yeah, this is a good problem to be solved with AI, but are we equipped to even take care of it using the AI? So these definitely are some of the important things that I would consider when we have to see how we can, ensure that one can invest into AI projects. All right. Thank you so much for that, Seba. Moving on to the next question. how can companies ensure that AI systems are fair, transparent, and unbiased? And how important is this for business? Uh, I think when OpenAI came up and some other tools, it was a big bang, but obviously it had its own challenges. And this actually becomes a critical question to address when we all want to jump into the AI. So Seba, your thoughts?
Well, that's a very interesting question, actually. And one of the questions I would say probably put a lot of the projects running behind, if you will. I think if we don't have the right approach to manage the data that we have in the organizations, these projects are sometimes set to failure from the get-go. If we don't have, I think companies need to have a different approach to how the data governance approach is being implemented across the board, right? I mean, and how the policies and guidelines are going to be behind that, because whenever we talk about that, if you don't have the right data and you need to trust a model to help you make decisions, then what is the level of confidence that you are going to have, right? So that's an important one. And on the other side is there is this huge amount of data that we are able to get nowadays, right? With the participation in cloud, or even if we use GPTs, any model that you want, if we don't make sure that that data is unbiased, that data is suitable to be used, we are going to be running behind in the scenarios that we need to validate, and we are not going to have the diversity that we want to have to make sure that we are not biased in the use of those models, right? Because we want to trust in the models, but at the same time, if the data is somehow biased into or limited in how how diversity is, then of course the model is going to react to what it was trained. At the end of the day, it's a tool, as we are saying, and it's being trained on that regard.
Right. Yeah, thank you so much for that, Seba. David?
So, yeah, Seba, absolutely correct. I would say that there's kind of two angles to this, and I would start by prefacing to say that as QA practitioners, right? I mean, we have a responsibility on how we look at this, right? And again, I'm one of those guys. We got a speaker today, Michael Bolton, a colleague of mine, know him quite well up here in Canada. He's one that advocates kind of like me to the fact that, yeah, let's use these things, let's use AI, but let's also realize we have a responsibility as QA practitioners to adapt to the way that we test and secure and validate and be a gatekeeper to proper use of AI and proper deployment. And in the optics of that, there are changes, there are new roles, right? We're going to be called to collaborate with mathematicians and experts that understand the algorithms and implement these things, which it's a little bit of a different skill set. And I think so there's a couple of angles when we look at making sure that AI is something that people can trust. Transparency is clear, right? Understanding what the algorithm is doing. And sometimes this is complex. If we're using quantum calculations and all that, it's next to impossible to really understand. But in certain cases, if we're going to trust the system, we need to understand where it got to its answer, right? So there's a level of documentation of that process and making it public and saying, here's how these things are being calculated. Here's how these results are being generated. And then there's also the notion of, as you said, fairness in the data, right? Fairness in the data and making sure that we're calling upon data sources. And this is especially true if the data access is something that's evolutionary and changing and evolving. We as QA practitioners, here's a new thing, it's changing. So therefore we need to test it on a day-to-day basis, because what was true yesterday could be not true the day after based on inputted data sources, whether that's voluntary data that was added into the pool of data that it's pulling things from that might force us to change the algorithm, or involuntary, like where it's a poisoned data system coming from an external attack or something. These things do happen. So there's a whole kind of a new angle that comes up with AI that I find is extremely interesting. Tremendous power and great things that come out of AI, but we have to just be very careful on how we approach things, and that we as QA practitioners put the right gates around it. So that's what I would add to that.
Yeah, thank you so much for that, David. In fact, I think as companies evolve and as we practice more AI and we start generating these new models, going forward, I believe even the business users, stakeholders is going to ask for more transparency, right? Like what you mentioned, that yeah, it's going to be difficult to understand how and when and how did we reach this decision. But somewhere, I believe that this is which instead of being that as an afterthought, it's going to start coming to a foreground, that have you put how we're going to maintain the transparency, how we're going to explain the reasons why this decision was made. And because of that, we can go ahead and then understand, okay, probably my data was not right, or it was corrupted, etc., right? So yes, that definitely helps in getting better and better at building different AI models. So all right, thank you for that. And moving on to the next question. Sorry. Just looking at the, yeah. Okay, how can business balance AI-driven insights with human intuition and experience? Andrew, this is for you again.
Sure, thank you. First, it's important to recognize that you actually do need humans and machines working together. It can't be just the machines. And what we have found time and time again is that the partnership of human and machine will handily beat human or machine any day of the week. I like to think of the example of IBM's Deep Blue chess machine playing against Garry Kasparov back in the 90s, right? It was the first time that a machine had beaten a human at chess. And so it was fair and square. But then what Gary did is he turned around years later, is like, let's make super chess, where we have we have human players, but with the advice of the machine. And when they did that, they beat pure machines hands down all the time. And now super chess is kind of like a thing in that world. So you absolutely need that. You can't just say, oh, the machines are going to do everything. And every developer knows this, right? You try to use Copilot and VS Code, and there's like, this code sucks. But maybe like 70% of it is okay, and you can copy paste and kind of change it up because you as the human know where the problems are very intuitively. So so I think that's the second part of it, is to recognize you need both. But the way that you use both is you use it as like an advisor, as a coach, as an additional resource for information, and to be okay with that. I think a lot of people, when they type something into ChatGPT and they get a questionable answer, or most of it looks good, but there's one fact that's wrong, they think, oh, this whole thing 100% is horrible and broken. It's like, no, it's not. It's not completely right. But that's why you're there with common sense to be able to use that as a starting point. And when you do that, you'll find that you move a lot more quickly. You get a lot more done. You can be more efficient with that. And so I think that is the best way to balance, the human and AI together.
Yeah, thank you for that. Seba?
I couldn't agree more. I mean, it's really spot on. I think that AI is here to help us be more efficient, augment our capabilities, do our things faster or better, or in a more complete way, trying to not oversee things, right? Or helping us sometimes see part of the picture that we might be missing, right? I think it's a great complement to what we do. And I don't think it's 100% right or 100% wrong in every single answer, right? We tend to, as Andy said, we find a little mistake and we say, I don't trust 100% on anything on this. And that's not the way it should be taken. There is another front I would like to add is that with AI, there is a lot of thinking on, hey, I want to automate all these tasks so that I save money, I save time, I am more efficient. And that's fine. There are a lot of tasks that you can automate with the use of AI that can complement what we do in a day-to-day basis, especially whenever we talk about designing test cases or generating code for the test scripts that we want to create. However, there is a part where the human insight, the people insight is critical. And whenever we talk about taking a look at how the user experience looks like in everything that we are implementing, how is the usability of the software, right? Those are things that you need people to take a look still, because there is a lot of experience, there is a lot of background in what we are doing, and from our experience, what we do every day in our job. I mean, whenever we test, we don't overlook that, hey, this button doesn't look at a lot of accessible here. Hey, we may need to take a look at this. There's a lot of things whenever we talk about our capabilities that right now a model won't tell you exactly that, right? So
Right.
using our own background and experience to make sure that the user experience is great, right? It's also important because if something is not usable, it's not pretty, if you will, many clients will go to your competitors, and you are losing market in that regard. So
Right.
that's true value that people brings on the table whenever we talk about our capability.
Great. Yeah. Seba, and who better than the testers, right? To do that. So, yeah, I mean, so I think this is, even I agree, this is interesting because though we say it is true, but the human intuition, the human insightfulness for asking questions which probably the data is not covering, or probably during the development efforts it was not thought, but maybe a tester has thought about it, that hey, I know something is wrong with this, let me just dig it into more and find out what is going wrong. I'm going to break this and I'm going to make it say something which is not right, and I'm going to go back and say, hey, this is not right. So I think what I strongly believe in is that yes, human intuition is going to guide and give a proper insights into the data insights that the model is given. It is actually going to give a proper direction to the end users. It's going to help the business users, and it is going to steer the conversations or even the models into the direction to answer the question that is this what we are doing right, is this what the expectations from the business users. And if again, I would probably say if a test engineer can answer that question, I believe that yes, we have a good model over there. Of course, with metrics and all of these things in place, it is going to still matter, but human intuition just becomes an important part for the overall testing of the data model also. All right. So moving on to the next question. How important is collaboration between the business, tech companies, and governments in advancing AI? And Seba, this question is for you.
Well, I think there are many fronts here to analyze. I think we are seeing what is happening out there with fake impersonation around the use of AI and how is that impacting people, right? So, and people lives specifically. And I think we all need to have a commitment to try to stop that in all fronts, even technology areas and companies, but also, of course, going to the governments. And yes, I know there is a huge effort from governments in trying to put the right rules, the right policies, so that they protect people. I think there has to be a balance as well in what governments are doing, because whenever you put a lot of boundaries, then you are gonna hinder the creativity and the possibilities that the models can bring onto the conversation and the value that they are trying to bring as well. So there has to be a balance. I don't think governments alone should be working. I mean, collaboration, as we are seeing in some panels with technology companies or even with experts in the field, is critical so that you put the right policies in place. I think that is important. I mean, I don't think it's one front going alone. I mean, it's a joint effort between governments, companies, and businesses. And on the other side, whenever we talk specifically inside companies, we need to have the technology areas being the right advocates for the work that is to be done. I mean, whenever, as we said, we don't need to throw AI to everything, right? We need to have technology areas within companies helping understand the business, what are the benefits of using AI, what are the risks of using AI as well, and how we can do if you will, an ethical use of that within the organization. That's what I would suggest and tell about it.
Sure. Thank you for that, Seba. David?
So yeah, it's a collaboration. AI definitely has a risk factor to it, and it's evolving and growing very rapidly. I think the use cases of where AI can benefit society and and allow improvements is definitely there. But with that, there are going to be, as we say in Quebec, faux pas. So areas where we step into, areas where we shouldn't. I think that's where having policies that are applied, yes, with government involvement, yes, with private sector who understand, have expertise in these areas, with government governing parties, that are set out as consortiums to help kind of establish international kind of best practices on how to use this. It's a new world. I mean, as much as the internet
Right.
changed the world and allowed interconnectivity, and that first email that went out overseas and was instantaneously seen changed the way communication happens, I think AI is one of those big game changers, right? And we're privy to be part of that transformation. We're part of that change in the way that it is. It's a tool, right? It's not the end all of end all. It's not going to change absolutely everything in all the areas, and we're all not going to work anymore and go hand in hand walking in the fields together with nothing left to do. I think, as we talked in the last question, we do have an element where humans need to collaborate with technology and use that technology, and AI can augment. There's a reason it's called a co-pilot, right? We call it co-pilot. We don't call it pilot, right? It's not piloting everything. It does require our intervention, supervision, and so forth for it to be beneficial to us. And I think that in that optics, especially right now as things are evolving and changing, having that foresight and that vision and collaboration of all those different entities and parties, looking at each one of the use cases that come up as it pertains to AI is important. And I'm happy to see that there are those governing elements that are there and things that are happening. And it's that sweet spot between having it open enough that allows us to see the evolution and not put the brakes on everything, but also having it done in a guided way with certain boundaries around it that ensure that it's being used to the benefit of all and not negatively. Because naturally, like any powerful tool, it does have potential for problems if it's not used the right way. So.
Right. So in fact, David, I always feel that we need, like, it's a school. In school, you have different students, kids coming along. You tell them it's your playground. You do the innovation. You just go play, do whatever you want. But at the end of the day, you still need a principal, or you still need a teacher who's going to say, "Hey, let's discipline this." We don't want you all to be unfair. We don't want you all to be unbiased. We want this to be disciplined also. So somewhere, I believe, as we moved ahead, and with AI and Gen AI and new things happening in, I believe somewhere where there started happening issues like copyright issues and images getting stolen, etc. And all of these, when things started going in a direction where it was not meant to be going or not supposed to be going, I believe that the responsible AI, as we call it, right? The whosoever started coming up with it, they realized that there is a need for governments, for businesses, for tech companies to come together to form policies to ensure that we don't come to an end where AI takes over the earth and we all vanish from the earth, right? So I believe that.
You're right. It's definitely one of those elements, and I think one of the challenges is it spans internationally, right? So even if different nations establish certain boundaries around it, it's about commonality on what are the overall boundaries that we should apply. It's the same challenges that face the internet, right? On how we control certain things inside of that, but then again, not close it down to the point where we're limiting it in a way that we're losing the benefits that it can actually bring. So
Absolutely.
finding that sweet spot, like I said. Yep.
Right. Thank you. So I don't know, Andrew, do you have any comments on this particular point? Because I know this is like it's affected by everyone, right? Everyone gets affected by this, because innovation, sometimes companies can come back and say, hey, my innovation is getting curbed because of this policy. So your views on this, Andrew?
Yeah, I mean, we're all in it together. This is the brave new world. We can't avoid it. I mean, I do agree with what everyone else has already said on this.
Right.
Yeah.
Sure. Okay. Thank you for that. Okay. So in fact, you know what? we at Globant, we have come up with our own tool also, which is MagnifAI, and we strongly believe in that this is going to be like a good tool and for testing purpose, and we are actually we are seeing a lot of value that gets added, and this is where our teams keeps talking about, our leadership team keeps talking about, right, that let's build a responsible AI and Gen AI model, which the companies, the test engineers, they can see the value for it in they can go ahead and use it for their purpose. The idea is not about taking over the data or any of these things, but the idea is that let's see if we can have the value that the business needs and we can showcase the value for it. Moving on to the other question was, how can companies measure the return on investments for AI projects? David, for you?
I mean, standard best practices on measuring ROI, right? I mean, again, ROI, there are standard formulas around that. There's ways of
Yeah,
doing it. And I think the same elements need to apply. I think there's a lot of magic thinking right now, and AI is being thrown around all over the place as the end all of end all. I'm actually having overload of seeing AI thrown into every single phrase that's everywhere around it. And I don't think AI has a place in everything right now. So I think it's about choosing the right spots where AI can and should be used and calculating the ROI. So therefore, you need to have a baseline. You need to start
right,
with something. So what is your reality now? You're then
right,
deploying a change that's going to affect processes. It's going to allow additional tools, co-pilots, whatever that may be, elements like that, and then assess, are you getting ROI? And ROI is calculated in a multitude of different ways, right? There's monetary ROI. So are we
correct,
saving dollars? Are we capable of selling something more efficiently? Are we adding efficiencies to the team? Are we improving the quality of the responses that we're getting out of things, right? But the base over here is, and this is actually, I think this is one of the big problems in QA in general, right? We apply tools often to do things, and then we go off and say, hey, we automated a bunch of tests, or we did this. And then the business comes back and says, okay, so what does that amount to?
yeah,
And we
exactly,
know that it's better, but we haven't really quantified it, right? So we
right,
often miss the boat of checking the baseline, right? So start with a baseline, understand what your reality is right now today, right? And then say, if we're applying a change, we need to be able to quantify the ROI and then express that back to the business. And that's how you get additional dollars. That's how you improve funding into things. And that's how you can get to those next steps and the next step and the next step, right? So I would say it's the basics, right? But the basics start with understanding your reality prior to applying a change. So start with that.
sure. Thank you, David. In fact, that when you mentioned that point, actually, it's very funny. I mean, a lot of times we do get questioned, right? That hey, you have automated 100 test cases. Okay, let's see what is the ROI out of that. And yeah, and everyone is zapped. Okay, now how do I go back and say, hey, I saved your time, I have done this, I have done that? So it becomes an afterthought. And I truly agree that if we have to showcase the ROI, let's start with the baseline. Let's start creating a baseline to see what are the parameters that we are measuring. Where is there any business use case? Is there any operations that I am improving? Is there a value that I'm adding? It can be just like a customer support, right? But using the customer support, am I have I reduced the number of incoming test support cases that are coming in, or have I turn around the time, and have I now I don't need someone sitting 24/7 because I have my chatbot doing the test, right? So
Yeah.
that's a perfect point to put in. Thank you so much for that. Andrew, what about you? How do you think how do we measure the return on investments?
Yep. Same thing David said. It harkens back to what we said before, that AI is just another set of tools and technology, right? And so measuring the return we get for that is the same as any others. It just happens to be the new tool in the box. I would say we need to be cautious with AI because it can lead to runaway costs. Like if you're training big models over and over again, the compute power can be rather expensive. So
Right.
it's something that we shouldn't overlook. I would also say we should make sure to be using AI to try to solve new problems, not the ones we've already solved. Right? Don't use
True.
the AI to tell us what we already know. That kind
Right.
of thing.
So in all, does it make sense actually that instead of building your own AI models, you rather purchase something which is out of the box, get it trained, and then start using it?
If that's what makes sense, absolutely. Right.
So,
We don't need to build everything ourselves from the ground up these days, which is nice.
which is great. Yeah, exactly. Right. Okay. And now because I also wanted, because we've been talking so much on the AI and in AI front, and I believe that all of us for some time have worked on many of these. I don't know, Andrew, do you have any success case for AI which comes to your mind and you thought that, hey, this was really fantastic use case that the AI solved, and it helped in adding some value or business improvements?
Sure, absolutely. I don't have any like business cases to point to, but I can share anecdotally one case that in the small scale was absolutely mind-blowing and awesome. So my wife owns and operates a dance studio. She's got students who come in of all ages, from little kids to adults. She rents a commercial space not too far from home. And because she's the business owner, she has to do a lot of things that are not simply teaching dance or doing dance, right? She has to negotiate with the landlord on the lease, and she has to do contractors for special instructors. She flies in from South Korea for workshops and stuff.
Oh,
And
okay.
so there's a lot of there's a lot of business administration and legalese and documents and stuff like that. And English is my wife's second language. So a lot of times she's like, Andy, can you do the, can you review this for me? Can you write this for me? Can you help me with this? And so it got to a point where like, small things like whatever, you're putting a poster out there, fine. But then when she's like asking me to review or even write contracts for dance instructors from overseas, I'm like, baby girl,
I know where
can I
you're
show
getting
you?
with this.
Can I show you ChatGPT? It's like, what is this? How can I use this? Because she had heard about it, but never actually used it. She thought that was for these weird tech nerds like me. She's not in tech at all, right? And then I show her, is like, she go in here and ask it to do it. She tried it, and she comes back 10 minutes later, and she's like, this is incredible. This is saving me so much time. I don't have to write this myself. And so here she is as a dance studio owner and operator and instructor using AI technology to help her flourish in a human capacity, because all those mechanics of legalese and contracts and all, like, whatever, right? She's there to help people dance, and so she can do less of the grind work and more of the fun work. And I think that's a perfect case of what AI should be doing for us.
Absolutely. Yeah. Thank you so much for sharing that. Yeah, you're totally right. The time is that you don't want to spend your time on unnecessary tasks. It's rather left to someone else who can do it much more efficiently than what we can do, and we can do what we love doing, right? So thank you so much for that, Andrew. David, do you have any example to share with us?
I would share my own personal examples. I commenced using ChatGPT in a lot of cases where we get these one-off sort of requests to generate some form of a generic response to something, right? So we handle a lot of support tickets for customers on different products or things like that, and often we're asked, well, okay, we need a template for this or a template for that or generate a response for that. And in the past, the team would ask me, so Dave, how do we build this, or what do you want in that, right? And I said, like, guys, like, don't go spend 3-4 hours generating a template. Just start by having ChatGPT create something for you. Now, I'm not saying use that as a cut and paste and throw it in there, right? Because chances are it's not perfect and it's going to look like it's ChatGPT. But guess what? If that saves you 75% of the work, and you just got to tweak off of that, it's much easier to start off as something than to start off of a blank page. And I find that that's, for me at least, that's a personal example where I find ChatGPT has been a saver on time, because where I used to have to block off 3-4 hours or whatever to go out and build something and do it, that 3-4 hours is now reduced to 20 minutes, right?
Wow.
Review, adapt, change, add my color to certain things, make sure that it looks like me, or it looks like our company in the way that we want that message to be expressed. But the good thing is there are tremendous time savings, right?
Absolutely.
So I think that in a lot of the practical use cases for Mr. and Miss Everybody in this world, right? Those are some really great examples, right? I mean, and I think what you were saying, Andrew, I mean, a lot of people think that AI and ChatGPT is for the super geeks and the nerds and the data scientists and everything. I'm not saying it isn't. There's a lot of use cases that are very, very deep and complex, and the inner workings of how it works is something else. But I think that the most interesting aspects of what AI is doing is how it's going to be able to transform a lot of these day-to-day tasks for everybody around the world in little areas that we don't even sometimes think of.
Correct. Yeah, absolutely right. Thank you so much for that, David. Seba, how about you? Any examples?
Yeah, I have actually my own example as well while using ChatGPT and see other tools as well. I mean, we were debating with some friends in a project saying, hey, we need to validate this complex scenario. And we were all burning our brains trying to think on all the possible paths.
Mm-hmm.
And we got a huge amount of what we thought was a good coverage, right?
Okay.
That's what we thought. And we say, okay, let's challenge ourselves. Let's see if this is the right coverage. I mean, if we are not missing anything. And we started writing the prompt actually to use a very, probably not complex prompt, but trying to make it as complete as possible, right? With the variances and the nuances that we were able to think of. And the results we got is that was amazing. I mean, we were all shocked because yes, there were a lot of things that we thought about, but there were scenarios that we didn't think, and they were totally and absolutely valid. And we say, okay, we are missing these pieces of information and these pieces of scenarios that we need to add, and we started adding that coverage, and we ended up with a better coverage and a better quality overall over the product. But it was really nice to see that in action, and we did it as a group. It was a really collaborative effort, but all seeing the results, I think it helped us understand the benefits of using the tool.
Right. Sounds good. In fact, from my personal experience, for last so many months, I have suddenly started seeing that everyone is writing excellent emails. So, so that was a very big change for me, because I was like, okay, I know this engineer he used to write good mails, but they were never excellent. And then you realize, oh, where it's coming from. So yes, of course, AI has, and Gen AI has improved, and we as all community, we need to use it and ensure that we go ahead and develop a responsible AI where biases and everything is also tested and taken care of. So thank you so much, Seba, Andrew, and David, for all your insights and giving us excellent views. And for this, hope the audience had a good insight into this and they can leverage it for their further testing, development, and implementation. Thank you so much, everyone. Have a good day. Bye.
Thank you.
Thank you.
I would like to thank our speakers for such an interesting talk. Before we go ahead, I have an important announcement for you guys. We want to invite you to learn about Globant's solution to accelerate software quality processes with the power of AI. It's called MagnifAI. Explore how we are revolutionizing the testing cycle with advanced AI algorithms, ensuring quality checks early in the development cycle to help companies develop digital products that deliver a high quality experience to their end users.
Right. Moving on, next we will hear about generative AI-driven load testing. And our speaker is Vishnu Murthy, who is joining us from the UK. Vishnu is a distinguished member of technical staff and automation architect at Dell Technologies. With over 17 years in software engineering, Vishnu specializes in automation development and systems testing. His expertise includes over a decade in automation solutions and frameworks, and 7 years in storage products validation. Vishnu has also been instrumental in designing automation frameworks for CLI and GUI products. His innovative work is highlighted by 9 patents granted by the Indian Patent Office and USPTO, and 128 patents recognized by the Dell Patent Committee. Please join me in welcoming Vishnu. And before we cut over to Vishnu, let's have a quick look at a video.
Introducing MagnifAI, Globant's AI-powered solution for software quality assurance. By leveraging generative AI and computer vision, MagnifAI cuts down weeks of testing time to just minutes, making it possible to accelerate manual test case creation, leveraging large language models to transform requirements into manual test cases, speed up test automation code creation, allowing you to use prompts in natural language to generate code snippets that can be used within an automation framework, and automate visual testing validations, using computer vision to help you spot visual differences between designs and final outputs, and validate layouts, visual components, and development environments. It's like having a companion for end-to-end software quality assurance that delivers tailored outputs based on context and project-specific documents that can be easily uploaded to the platform. And the best of all, MagnifAI is designed to blend seamlessly with your existing development ecosystem, helping you deliver a digital experience to your users much faster. Are you ready to test smarter and not harder?
Yeah, thanks for the introduction. Today we're going to talk about generative AI workloads, how we can able to use these workloads to test the GPUs actually. And hi, all, this is Vishnumurthy, distinguished member of technical staff and working for Dell Technologies. Uh, let's go. Let's find what is the today's agenda in this talk actually. When today's presentation, I'll be covering mostly on the what is a GPU and introduction to the GPU and what is the difference between the CPU and GPU. And I'm also introducing the generative AI technologies and what tools we have in the generative AI technologies, and also how do we actually generate and load testing on GPUs using generative AI technologies actually. And also we have a slide demo under the presentation which can help us to get the more details on the same thing. Okay. So, introduction to the GPU. I think right now we are actually listening a lot of generative AI. Oh, okay. Sorry for that. Okay, share it.
And also, Vishnu, there's a lot of background noise. If you can just take that.
I put the headset. Yeah, see. Share. Window. Presentation. Share. Are we good now? Okay, thank you. Sorry for that. Okay. So yeah, I'm going to introduce the what is GPU and how the GPU and CPU difference and all the stuff, and little bit introduction to GPU. What is GPU actually? GPU is a specialized electronic circuit designed for accelerating rendering computer graphics. Mostly, this was designed for the all the graphic intensive tasks actually. Previously, we used the video games or 3D modeling and all the stuff, but recently the AI generative AI technology was ramped up. The GPU are extensively used actually. Okay, and now we are hearing mostly the GPUs by the NVIDIA and AMD and the Intel GPU cards, how they are using, what they are using actually. So we'll discuss a little bit more details about the CPU versus GPU, then we get the tools what we are using. Um, The high level difference between the CPU and GPU you can see in this picture. Basically, CPU is called central processing unit and GPU is called graphic processing unit. CPU is basically contains limited number of cores, 48 cores, and GPU contains more cores actually. Due to that, we will be able to CPU can only do the serial processing and the GPU can able to do the parallel processing actually. And traditional applications like word processing, web browser, and all the video playing, all the things will be used in the CPUs, and the GPU is majorly used for the video rendering, video editing, and also the generative applications because the multi-cores are available. The task will be parallelly processed by these cores, and we will be able to make the task more faster and easy actually. Okay. So we talked about the what is GPU, what is the CPU, what is the CPU and GPU differences. Now we're going to talk about what is the generative AI world and what is the technology we use actually. What basically generative AI is basically we will be able to generate the new data using based on the existing data what we actually created. So uh, basically where we use this one to create the automated content creation which can help us to save a lot of time, and we can also use creatively what we have actually used previously. Okay. And now the extensively the and generative AI using across the world, there are two things which you will be hearing across the world. One is basically the training, another one is called inference. The training is basically to know the creating a model based on the data which exists in the world actually. That's where we will be creating the models and it's called the training actually. So it's intensive, very intensive work. It takes a lot of GPU systems and cycles to create this model. And recently you can be hearing about this Facebook Llama 3 model and all this stuff. What is the inference? Basically, it's help us to create a request a data from the models, and it generates the data using this particular models actually. You can talk about like in a text to text where the really chatbots, and also the text to image like stable diffusion or the any other text to image generation ones. So what we see is that training is one aspect, inference is another aspect, and training creates the model, inference actually use the model and generate the data from the what user request the prompts actually. Okay. And what type of applications we see in generative AI? I think a lot of people knows these applications what we are hearing. One is basically called text completion, image generation, music composition, and video generation. And text completion is pretty much like what we are using in Chat GPT and OpenAI and all the stuff. And image generation, basically you can ask a prompt and it will generate an image actually. And these two applications and more details will be covering as part of the demo and the next slides. And music composition basically same like music composition and video generation, where we can ask a prompt and it can generate a music and it can generate a video actually. And the next slides where we talk about more on the text completion and image generation, and also we will cover about in the video in the demo also and the next steps. So as I mentioned in the previous slide, we will be talking about two major generative AI workloads. One is basically using the stable diffusion. What it will be? This is a web interface built on a stable diffusion model, and and this is again most of the tools what we talk about in this presentation are in open source world available. You can able to download and you can deploy on the system and you can use these applications. And this is one of the application where I'm talking, where you can able to give a prompt, text prompt, and it can generate an image based on the prompt which you provided. Okay. And this application also have a REST interface, open source, and all the stuff. With using that endpoint, we can able to automate and we can stress the GPU. And another application is basically Dell. Pardon? Sorry. Fan. Okay. Sorry. Sorry. I'm in a presentation mode actually. Slides. I don't know this. Are you seeing the presentation mode or are you seeing this PPT actually? What is that? Just a minute again. Enter screen. Are we good? So yeah, these two applications we're going to talk about in the demo and the next steps also. Basically, these two applications we are taken as an example how we can able to use these generative AI work applications and able to stress the GPUs actually. So yeah, so we'll go into that how exactly we use these applications as part of our system testing or non-functional testing actually. I think most of the people knows that non-functional testing and system testing what exactly, and I'm just going to give very high level. The system test or the non-functional test is basically focus the customer workloads and the way the customer uses the systems in their data center. Okay, and what we do is that we try to simulate the real world customer use cases using the typical applications what customer uses on the servers, so that we will able to check that how the server is performing before we release the server into the market actually. So some of the typical workflow or what you call it, the flow in a data center, what it will happen if you look at it. And when a customer bought a server, he will be deploying the server in the data center lab, and he will try to he deploy the application what he is going to use it, and then he try to run over the specific time, and then he will be updating the patches, security patches, and all the stuff, and he will keep monitoring. They will keep monitoring the system and its performance. Once the specific period of the system is over and they will be done, and when it's reached end of life cycle, they will be go and retire the system. So entire the focus of this presentation and how we are going to what we are going to learn from this is basically what type of workloads customer uses and how do we simulate that workloads in our lab to make sure that these particular systems are get utilized and stressed, and in a particular period of time to make sure the system performs well in the testing period actually. So we'll be focused more on how we actually simulate how the customer actually run in their data center in the same way in our lab actually. Okay, so what we're going to talk now is that what tools we use and how these tools will actually stress the GPU systems or the generative AI workloads and extra. So I'm going to talk about a small tool which we are actually built in on the with the open source tools, and we are running in our own labs actually. We call it as a Generative service. What this tool has is that all the components in the tool are running with an open source tools. Actually, if you look at it, JMeter, Docker, and Elasticsearch, and all this stuff. And this tool help us to build the new workloads like generative AI, a database, or a mail workloads easily in our labs. And it enables you able to automate all the aspects of the deployment and execution using REST APIs, and which also have advanced dashboards and visualizations using the Grafana and extra all these tools actually. So I'm going to go a little bit more detail about what key technologies we're using, and most of these technologies are available in industry as an open source technologies. So anyone would like to expand their, anyone wanted to use it, they can feel free to use this particular aspects tools in the lab. So some of the technologies what we're talking about is basically first one is JMeter, which help us to simulate all the workloads, all the use cases, and all the stress scenarios for us. And it also supports multi-threading, and it runs on all the operating systems also. And it's an open source solution. And then we also talking about the Dockers and Docker Swarm, which basically help us to orchestrate the Dockers and also load balance the Dockers what we are building up. I will give more details in the next slides where how this entire solution works and how it will orchestrate the things. And again, Dockers are basically, most of the people are replacing virtual machines with the Docker, so because it's portable and it's easy to, it's very resource efficient, and it's easy to disposable also because you can quickly bring it up and run the task and dispose it more faster. And the last one is Elasticsearch. Basically, what we do is that all the transactions, all the data what we generated for this entire workload stressing, we'll be storing in this particular database, and we will be accessing this data over the Grafana interface. And again, this particular Elasticsearch database is very known in the industry, and it's a schema-free and RESTful API-based database, and it's again an open source database actually. Sorry. So this particular slide, what did we cover is basically to make sure that how the entire orchestration happens and how the load generation happens and how the containers will come up and stress the systems and all the things will be explained here. And what we are going to talk about whenever a user comes back and asks specific situation where the user wanted to run a workload on a particular system, he comes to the particular application and asks for a particular, he asks for a specific workload and asks for a number of users and all the stuff. So that what it request will goes to the load generators and it creates a service. The service basically called in the world creates the Docker containers in the backend. These containers will have a JMeter script, which will be running the Generative scripts where it can talk to application, which is basically a load generator application. It's basically a generative application over the network actually. So when the container comes up, it has a Generative script which will be performing the continuous operations on the generative AI application, which basically requesting different prompts and generating expecting a response from the system under test. Using this way, we will be continuously sending multiple users with multiple prompts at the same time simultaneously. Due to that, the system will be performing all these operations and responding with the results. In this process, the generative application indirectly stresses your GPU in the backend actually. So all this data, what we are generated using the load generators and all the data which we're sending from the system will be collecting the Elasticsearch, and this data will be accessed and visualized in the Grafana. So this is the end-to-end flow of a entire application, what it running in the JAS. So what we are trying to explain in this particular solution is that using all the open source tools, we can able to integrate and make a mini solution which can run in our labs or in your system, which can run continuously a multiple. It can simulate multiple users and run request your application with the different prompts and generate indirectly a stress on your system actually. And we'll discuss more details in the demo, and we will have more clarity. We'll get more details. Okay, so this is the lightweight application which we built on React application actually, where the user can come and request for different workloads, and based on the workload, we will be creating the containers in the backend. We will orchestrate the containers. These containers will continuously stress your application actually using the interface, using your application layer. So yeah. So I talk about two applications. These two applications are available in GitHub. You can able to download and install on a system. These applications can run on a CPU as well as GPU actually. And these are both applications are available in open source community. So one of the application what we're talking about, chatbot, Dell AI chatbot. We have installed on one of the system this chatbot actually. You can see that this chatbot installed on our system, and then you can ask any system specific requirements, like just for a demo purpose, we're asking saying that can you explain about a particular server details. So what it will do is that it will send this request to your system, and the system has where this particular application running take the request and perform the operation and respond back with the results actually. So we can see the load which is generated on the GPU due to this request at the same time. Now we have another application. It's basically a stable diffusion. This application also we installed on the server, and this is also again available in open source community, and you can deploy the application. And this is the same example where we are able to request for a particular prompt, and due to the prompt request, the system will be respond with the results, and at the same time it will be using the GPU because that will be stress the GPU actually. Now we're going to get into more details about how this will be run in our labs with continuously for the specific time. So we have actually selected a particular application, Dell AI chatbot application, and then we requested for the number of users. Then what the chatbot application will, what entire JAS will do is that it will create the number of containers in the backend. Oh, sorry, I'm hearing a lot of noise. Anyway, so once we send the request, basically the JAS will create a Docker service in the Docker Swarm cluster with the specific number of users. Just for a demo purpose, we ran one service with one request, one user. So we can see the container came up in the backend of the service. With the container, we have a JMeter script which continuously stressing your system actually. Okay, sorry for that. So once your container started talking to your application and generating the requesting continuously, your system will be get stressed on the GPU. We can keep monitoring that in this particular Grafana dashboard about all the data which we're collecting from Elasticsearch. Now, we know that we are actually getting around like 70% of utilization of the GPU, but we would like to hit 700% of the utilization on the GPU. So we will be running another workload parallelly on the same system, which is basically text to image based workload. running on the Stable Diffusion web application. So we started another workload, which basically started the same process where it runs as a service and the container will come up in the backend, and this container will be stressing your system. We can see the utilization is increased to the 80%. Okay, so what we are doing here is that we are running two parallel workloads. One is basically text to text generation, another one text to image generation. Due to these two workloads parallelly running with multiple users asking different prompts for the text as well as different prompts for image, these two workloads running on the system will be extensively using the GPU, and it is utilizing all over 100% of the GPU over the time. So we will be continuously running this particular workload for the 5 days, and we will see the system, how it's performing, its utilization, and it's also the system overall performance, like the fans and all the system entire peripherals. And we continuously monitor and check. And then once we run the workloads over the time, we will be also have a control to stop the workload, which basically help us to weigh down the workload. Okay, so what we are looking now is that we started working. We started actually going into the retire phase where we will be we will be terminating the workloads that we started. Due to that, the GPU will be utilization will be reduced over the time, and you can see that the GPU utilization was gone down, and also we can see the same utilization from the Grafana dashboard. Also, the utilization will be go down. Okay, so that's the demo from that's the demo what we are what we would like to show it up. But in the total presentation, what I would like to tell you is that we will be using generative AI workloads to stress the GPU to make sure that the GPU will be stressed and properly verified and tested before we releasing the systems and GPUs into the market. And the application what we used is built on open source tools, and the GPU workload what we used also in open source tools, so that we can anyone can able to explore these tools in your real-time product testing or any your application testing and all that stuff. These tools also help us to make sure that the GPUs are extensively stressed and able to run it over the time. Yeah, I think that's pretty much from my presentation, and I would like to open for the questions. And sorry for the rush up and also the presentation hiccups actually, and very sorry for that purpose. Sorry. That's pretty much from my side actually. Any questions we have?
Yeah, it's on site.
All right. So one of the, I believe there's a request which is asking for the links that have been. So whatever you were speaking about, Vishnu, if you can please post those links on chat, that will be appreciated.
I will do that. I'll do that because I will be attaching the slides also, so that people can able to refer the links and able to look into that actually.
Sure.
Absolutely.
Great. Thank you so much for your time, Vishnu. We really appreciate it.
Yeah, thank you. So thank you. Sorry for the hiccups actually. Thank you. Thank you very much.
Thank you. Have a nice day.
Thank you.
All right. Now let's talk about overcoming the loopholes while using Gen AI for testing in an interesting panel discussion from across Europe and the US. The speakers on this panel are Aaron Evans and Grigory Goldstein from the US, Benjamin Biskoff from Germany, and Vlad from Romania.
Aaron is a test automation strategist at OneShot, with more than 20 years of experience working at a wide variety of companies, from nimble startups to leading enterprises. Aaron helps companies build better software faster. He specializes in test automation and continuous delivery using cloud services.
Benjamin is a test automation engineer at Trivago. He is focused on modern technologies and standards, creating ideal user experiences and everything concerning code craftsmanship and software testing.
Gregory also known as Greg, is the manager of quality assurance at Fox Networks Group. Greg is a visionary QA leader who has built QA teams from the ground up, developed processes, procedures, and operational guides for the QA organizations. His experience in quality test engineering have equipped him to focus on finding issues and fostering a quality-centric mindset among teams.
And lastly, Vlad is a technical director at Globant, and he is going to be the host for this panel discussion. Vlad has experience in testing web, desktop, mobile, and APIs developed in a wide variety of technologies, and he also loves to mentor and coach other people. Thank you everyone for joining us, and the stage is yours.
Good day, everyone. Glad to be here. Glad to be hosting this talk about AI and how AI can help us. Of course, AI being such a vast domain, sometimes it might produce confusion around it, right? We see AI integrated in laptops, phones, software development, photo editing, basically almost everywhere in our life nowadays. So in testing software, AI could not be missed, right? So today I'd like to bring a topic which is very, very popular, like overcoming loopholes while using Gen AI for testing software. What do we mean by loopholes? Well, let me give you a couple of examples. For example, an incomplete testing strategy, that might be a loophole. Wrong test data or lack of regression testing, over-reliance on test automation. All of these things create loopholes in the testing process, which can lead to flawed software products, missed defects, and of course, ultimately, if you are to think from a customer perspective, there will be a negative impact on them. So AI comes in as a companion. So regardless you're an early adopter or you will become an adopter in the future, definitely AI can help us. So we'd like to speak about these topics today with our three speakers that we have here, Aaron, Benjamin, and Grigory. So welcome, guys. Welcome to this talk. I have a first question that I'd like to ask you. And of course, I'd like to have an open discussion around it. So feel free to jump in and discuss around each of these answers, right? So let me start with the first one. If anyone right now would like to start integrating AI in their testing strategy, what would be your first advice? And one more, which is related to this one, how much coverage do you think can be achieved from a testing perspective if you are to use traditional tools and generative AI? So who want to break the ice here?
I guess I can jump in. So I think the first initiative, if you're trying to integrate AI in the testing itself, I guess like you have to understand the limitations of the Gen AI, what it can do and cannot do, because there's a lot of buzz in the industry in terms of Gen AI, and everybody is jumping on the bandwagon. But at the same time, you have to understand the capabilities that exist today. Obviously, in the future, it will change, but let's say JavaScript for you, if you just build in something that can create code with a Copilot. But a lot of those Gen AIs today, they're helpers. They're actually co-pilots. That's what they are for the most part. And when you trying to integrate it, you first have to understand the accuracy and reliability. And it's in many cases is a big if. Like I work with many tools that actually use Gen AI for test automation, and it's a hit and miss. Like sometimes it will come up with a correct result and whatever is expected out of it, and sometimes it fails for no reason. So it's not totally there yet. So you have to, I guess, understand this integration of Gen AI and what it can do for you.
No, absolutely. Absolutely, I agree. We cannot use AI for everything, but if we are using it smart and we identify where it can fit, it can definitely benefit, especially on the speed of delivery, the quality, the completeness. Those are the kind of things we are always looking, right, as QAs.
Yeah, I totally agree with that. I also use a lot of AI tools, but also as tools, not as replacement of something. And you have to be aware that you have to know about the subject and the software under test a lot, even though you use AI. This cannot do it for you. So you also have to be able to spot when it hallucinates, and this you can only do when you have the knowledge yourself. Of course, it can help you speeding things up, but I always consider those AI helpers as a very elaborate rubber duck that you can have a conversation with and develop your tests with, but it cannot, in my experience, do the testing for you.
I love that rubber duck example. I've used that one myself. It's nice to have someone to talk to, even if it's a computer. I guess I'd just like to add that I think there's a couple of concrete strategies we can do to start integrating AI. And the first one is to just follow good, practices, have specific goals, and set realistic expectations, and then measure your results. The second, which I guess should probably be the first, is to experiment with it, play around with generative AI tools, whether it's ChatGPT, Gemini, Llama, or whatever. And then secondarily, to compare what the features of specific AI testing tools can do and see if it meets your requirements.
Absolutely.
Oh, sorry. I think we totally forgot the second part of your question about the coverage.
The coverage, yes.
Yeah, and I would say don't worry about the coverage, because this should not be the primary goal about the test automation, to cover a certain percentage of cases. But so much is being said about coverage, and I think it's more important to have good test cases and cover the happy and sad path of your business logic, and not worry about having 90% or 100% coverage, which we cannot achieve anyways.
I really like your comments, man. Yeah, I have down in my notes 100% should never be the goal, whether you're using AI or traditional tools for automation. I also think that AI can do a couple things to assist in identifying areas to cover, but we're primarily limited with general AI tools with the number of tokens we could feed in. It would be nice to have an expert system that has our domain knowledge, our code base, our wiki or documentation, and be able to do analysis on that. But with the existing publicly available models, that's not realistic in a large sense. But it can help us to identify, cases that we may miss just by doing textual analysis. But there also becomes privacy concerns when you're putting domain knowledge into a public system. And I think we're going to talk about that more later.
Absolutely. We have
I was gonna add something to it, is the fact that some of the commercial tools that are becoming available today can actually do some analysis based on your code base and what test cases are covering. And some of the AI can analyze your existing coverage, like as far as the test cases go, For instance, an example would be CLights, right? So CLights has a capability where you have your code base and you run your test cases, and it actually kind of maps what's covered in terms of the code itself, and it gives you like nice reports, and you can actually analyze and see what's covered, what's not covered.
All right, now talking about specifics, right? Let's dive into maybe a more particular question. And usually these kind of questions are being asked, especially by the test managers. How can we use GenAI to improve the automation of regression testing? Because definitely regression testing, best friend is test automation, right? But how can GenAI improve that? And also, do you see any risk to use only AI in test automation? What would be that in case you do?
Well, I think it can certainly help speeding up the development of frameworks, pipelines, and the technical part of it. But still, I stand my ground that I say you have to have knowledge yourself to really assess if this is a good solution that it gives you. Like recently, I worked together with a lot of different LLMs because I had to do some DevOps stuff. And at one point, my assistant became so frustrated with itself because I kept saying, no, you have a bug in there, you have a bug in there, this is the old bug you had before. So instead of me becoming frustrated, it became frustrated. So you really, like I said, you have to have a good conversation with it. And sometimes this takes longer than just writing the code yourself.
All right. Do you see any advantages? Of course, there are risks associated with it, but can you identify any advantages with this approach where you use GenAI for test automation?
In some cases, it can speed up the development. It can certainly help you learn something, especially the resources that give you also the links where information is from. That works quite well, but still you have to be careful at all times about what it gives you.
Yeah, again, I like that answer. My favorite use of AI tools is for learning, for finding answers, ChatGPT, Llama or Gemini, whatever. And I like to compare the different results from different models, because that can also sometimes help us to identify either different things or where there's contradictions and help us to be suspicious or to find the right one. It's very much like using a search engine like Google or a knowledge base like Stack Overflow, in that there's both correct and incorrect answers, and finding the correct answer can sometimes be frustrating. But I think the textual interface of an LLM being able to have more context than a search engine, and we see that getting added to search engines now, is the primary benefit that we see using these LLM tools like ChatGPT.
And also I can add to it in terms of some of the integrations of GenAI, these test automation frameworks. So it's very challenging today because it's not a lot of open source, so you run into different limitations. But I didn't see like a lot of the open source kind of abilities to. So it's something that we can consider in terms of like overall impact on the test automation. But there are like in this example, there are successful implementations as well. They're just not free.
Yeah, I just also thought about an example that I recently had. those tools also help you a lot, I think, with making sense of stack traces, of log files, of like anything that takes a long time to scan through and overwhelms you. Those are really nice. Also explaining pieces of code that you don't understand at once. Also really good, in my opinion.
Yeah, absolutely. Plus, not to mention the capabilities of doing even code review, applying some standards, right, throughout your code. So this is also a learning procedure, let's call it like that, right? You can get more lessons out of using that as well, not just to serve you like, hey, I need an answer, you're providing it, and that's it. It's also like a learning, you're learning along with it, you're getting better. Nowadays, I'm working with the customer, and we are trying this AI techniques over there, the generative AI, to look over the requirements, right? We have good requirements. This is the prerequisite. And we are getting test cases out of it. Either it's normal test cases or are in Gherkin format. But one of my concerns there, or one of the problems or questions I need an answer to, is whether I'm getting false positives or negatives during that, right? The construction phase of the test cases. Now, what steps could we take to mitigate the risks of using AI when we are building false positives and negatives?
So I think the human factor is, at least currently, the deciding way that while AI can generate code or analyze text more rapidly than a human, we need to still engage our own mental gears in using our domain knowledge and common sense, for lack of a better word, to make sure that we don't have incorrect assumptions in code generated by AI. And the tricky part is that it can usually generate simple scenarios very quickly, but in more complex or subtle cases, AI can definitely hallucinate or get stuck, as you were describing in the DevOps situation, in a loop where it just doesn't seem to understand the problem and keeps reiterating the incorrect solution. The real risk here is because it can generate either requirements analysis or code quickly, that we don't engage our own mental gears to do the analysis, to do the QA on what's generated by the AI system. And frankly, you know, the amount of time spent typing has never been the bottleneck in creating code. It's the mental capacity of determining what's correct and what's missing.
Yeah, you should definitely make sure, independent if you created the test case yourself or let it create by AI, that it can also fail in the right circumstances. So that you should definitely do. Try to make it fail. And also, I really like what you said about the amount of test cases it can generate. I recently heard, and I forgot who said it, that if you have a pull request that you review that is just a few lines, you're very picky about that. But if you have a pull request with 500 files, you say all looks good, and then you accept it. And that's also the danger.
The most common comment on a pull request, looks good to me.
Yeah, exactly. And this is also the danger if you let AI generate 500 test cases for you. You will not check each of them.
Yeah, so I can second that. Yeah, so in our case, we do have SMEs, and I think it's very important to have someone to look over who understands the business logic, because I think Gen AI is really good at very discrete and concrete tasks, and it can generate a very good description of the test cases. Even if you look at Jira, now it has like ability to summarize your writing or rewrite things in a better way. And that's definitely an advantage. But like somebody who knows the application inside out, and the back end and the front end, and how the microservices interact, that person knows whether GenAI test cases were generated correctly.
No, and there is another example, because it's very fresh in my mind, is I had this huge requirement. It was like mostly like an epic, right? It wasn't necessarily split to the story level. So I was trying to see how many test cases that will result. And it was like Benjamin mentioning previously, not 500, but definitely a lot of them. And when you deal with many situations like that, and you produce like, I don't know, 300 test cases per sprint, then you're in a problem, because you need to filter all of those, and there will be a lot of manual validation there. But manual validation is needed. What Aaron was mentioning, human factor cannot be excluded out of this. I mean, we are still at a phase where we need some double checking, right, to make sure that whatever is being produced has value behind and also targets the right functionality. All right, so what are some best practices? Another question, what are some best practices for integrated AI-generated test cases with traditional manual testing methods, right? Because we've talked about if those test cases are okay, what do we need to do? But what would be some best practices for integrating these test cases into the traditional model that we all know?
All right, I'll go. So I think, like I iterated with automation, just good project management, setting expectations, measuring results. And also, I think that there's two specific things for manual test case generation. Number one, it can help with spelling, grammar, phrasing things better, which definitely helps for writing manual test cases. Analyzing requirements to come up with scenarios is another possibility. But an important practice, and we've already touched on this with the human factor, is to QA your AI to make sure that it's good. And just like automation, we can get overwhelmed with quantity. And so we want to focus on quality over quantity. And an AI analysis of test cases generated by AI may be able to determine which of these are potentially redundant or less valuable. Although, again, there's a value judgment there.
I can second that as well, but I would like to add a couple of things. So it actually helps to have another AI interrogate the original AI. We kind of touched based on it, but I did a really good experiment through APIs, where you can make, let's say, an API call to Gemini and make a same API call to, say, ChatGPT, and you can feed the same data in different places and see how the other engine refines the responses.
Yeah, and that helps to break the logical dead-end loops that they can sometimes get into by feeding the output of one input of another.
And it can also help you determine if you have redundant test cases or if you have tested certain parts in other cases before, but only if it has access to your current code base or your test case base,
Yeah,
however you want to
your requirements
call
and
it.
documentation or whatever, right?
Yeah.
All right. So talking about in the very beginning, we're talking about the ethical aspects, right, of AI and how we can share specific data, or if we can share specific data to AI. Will it imply any legal concerns or any legal actions? How should we handle these ethical concerns that arise when using AI in testing? So I'm talking mostly around privacy and data security here.
What we do internally is we have our own models that are trained on our data to not have this. And if we use third-party options to really make sure, also with the help of legal, that they cannot use anything we give it for further training. I know it's a matter of trust oftentimes, because those companies can be super new and they can have data breaches. But yeah, where would you stop? Because if you really think about that, you cannot type any information into anything on the web.
Yeah, I think different organizations will have different tolerances for what. For example, if you're testing a public website or a slightly different version of your public website, you know, that's the functionality is publicly available, and that might be okay. Or common areas of knowledge like e-commerce or whatever tax law are public knowledge as well. So there may be less risk in certain areas than others, but having a private model or a private instance of a cloud model may be a solution going forward. But right now, most organizations don't have the means or the expertise to be able to do that. I'd like to see that going forward. And I think expert systems that can mine a company's internal documentation and code base, email and Slack and stuff, and be able to draw inferences from that based on also expertise training on the domain knowledge, where you can correct and incentivize the models. I'm very optimistic about that in the near future, if we don't end up in a situation where only, you know, ChatGPT, Google, Facebook have models that we can access. But open source models and access to, you know, be able to spin up your own GPU clouds, give me hope in that respect.
I think it would be also great if these models will essentially evolve where we can deploy it on the private clouds more easily, and they will be up to date, because you usually get either older versions or not consistent version in terms of what's available, but also the capabilities, right? Like today, the commercial capabilities, like the paid version of, say, ChatGPT, is not producing the same what you get with a free version. And in that regard, we actually have internal GPT that we filter, that company-wide is suggested to use, because like, you're not exposing company-specific privacy info outside. And even it depends on the company level or comfortability level in terms of what we can expose, but APIs are very sensitive. So for instance, I know that with the version 11, now we have new capabilities like chatbots for API testing. But many companies have disabled, let's say in the Postman, this capability, because they're afraid that the API data can be exposed to third party.
Yeah, absolutely. So talking about these concerns, right? We feel like sometimes AI is used a lot, right? And sometimes it might not be in the right context. But if you are to start a new project where you have to use AI, right? Because that's the way it was pitched, that's the way the customer also is interested in. But let's say the environment is not the most favorable, right, in terms of AI, and the customer might have a lot of questions. What would be your strategy to buy in the customer with these AI techniques? AI tools, and so on?
So I think if you pitch the project with AI and you don't really know what you want to do with it, that might have been a mistake from the start. This is actually being done a lot. I see that especially on LinkedIn, where companies say, okay, that we are integrating AI now, and as far as I can see, in 10% of the cases, it might make sense, but a lot of companies are doing that just to say, we're using AI too. So yeah, it's not an easy question to answer because we haven't been in a situation like this. Maybe Gregory or Aaron have.
No, I don't have an easy answer other than to hark back to my first point, which is to have specific goals and set realistic expectations and measure the results. I think designating a specific project or a trial is a good technique at first. One thing I really saw a huge benefit for experimenting is we had a hackathon and different teams experimented with different AI specific tools or using general LLM to try to find ways to find solutions. I think those kind of bounded experiments are a great way to dip your toes in and to maybe plan for a next stage of adopting it for real usage.
Definitely. Also, I was going to give a quick example. For instance, we did a POC as well on the test automation side, and we tested different platforms that exist today to see which platform can do mobile API testing, like end-to-end cloud solution. And we did, for instance, Mabel. And what we found out is for our cases, it helps a lot with some of the new technologies that exist. For instance, the auto healing, right? It's very common now. You know, where it used to be Selenium, Appium scripts that break a lot and require a lot of maintenance. Auto healing helps quite a bit. It cuts down on maintenance significantly. And it's like very common nowadays across many tools. But also things like Gen AI can categorize failures. And it used to be that you have the report after the test run and you have to manually kind of sift through and to understand what those failures are. It takes time even for somebody who is on a high level of management. And also it cuts down on the amount of time to create, for instance, assertions. Whether it's API assertion, UI assertion, nowadays all you have to do is write even like a single sentence and say like, hey, I have this screen and it looks like it might be a sporting event. Can you verify that this is a sporting event? And it will spit out a reasoning like what it found and why the test case passed based on the Gen AI kind of assertion. It's very detailed. It will analyze the background. It will analyze the scoring. It will like look at the entire picture to determine what it is.
It's really nice that you said that, because up until this point, I thought that we would agree on everything, but finally there is something that I disagree on, and that's the auto healing, which I absolutely hate. I don't want that because I want to be in control. If something fails, I want to know why it fails and not magically pass again. And instead, what we're doing when it comes to UI end-to-end tests, we are working on making our locators super resilient by having data QA attributes on everything. We can actually do that ourselves in the QA team and just do pull requests with those locators and selectors. And this is a personal thing that I do not like, this notion that all the tools now have auto healing. but this is something we can discuss forever, I guess.
So record and playback tools have had auto healing in quotes forever, right? I mean, tools like Quick Test Pro did that 20 years ago, probably to a much worse extent than a tool like Mabel does nowadays. But I think one thing that's good, and you see this in visual comparison, which is an aspect we haven't talked much about AI, tools like Applitools use fuzzy logic to compare images to see if anything has changed visually on the site, which is a useful capacity in its limited sense. But I'm kind of in between you two, in that I think using fuzzy logic of the same sort to correct locators is good. But I like how Applitools gives me the ability to review any visual changes. And I don't have enough experience with AI test tools to know if you have the option of either auto healing or stopping with a failure and reviewing the suggestion. That would be a great feature if it exists. But I think in general, we can measure things like the cost of maintenance, time, whether automation is missing and bugs are escaping, and whether or not we're detecting through manual review that the requirements are being properly covered. That's kind of at a holistic level. I like Benjamin when you said being able to create robust locators isn't an automation or a testing problem, right? It's a code structure problem. Adding IDs or data attributes on elements and properly structuring your HTML or your mobile app, right? On iPhone or Android, accessibility tags are the best way to make automatable mobile apps, and accessibility and automatability go hand in hand with being able to craft that code. And we see, I think, partially due to generative AI helping to build with these very heavyweight front-end web frameworks, for example, things like React and Angular, that there's a lot of boilerplate code generated, which tends to make the applications less well-structured and more brittle to automate.
Yeah, and also a lot of random names for elements that change with every deployment.
Yeah, and we saw the same sort of thing. Again, I'm being the old man shaking my stick at the wind. We saw the same thing with HTML generation tools like Front Page and PageMaker generating ugly HTML 20, 30 years ago.
Yeah, this seems like a very, very vast domain, and I really like where the discussion is going, but we are unfortunately up to the end of this discussion. Guys, I'd really like to thank you, Aaron, Benjamin, Grigory. Thanks a lot for your time. Thanks a lot for all your knowledge that you've put in front of us, and yeah, looking forward for the next one. Thank you, guys.
Thanks.
Thank you for your time.
Thank you.
Well, that was a very insightful session. I'm sure our audience got to learn a lot from the session. Before we move ahead, we have another important announcement to make. Globant will have the next iteration of the next conference coming up soon, and it's named QuaNTA NXT Latin America Edition, and that is scheduled for the month of September. This conference will bring together experts who will delve into the latest technology trends, covering topics such as artificial intelligence, performance analysis, and augmented reality. We are providing the registration link in the chat for you to register and secure your spot so that you can be the first to know what's next.
We would now like to welcome our next speaker, Ariadna Truba from Spain, who will speak on the introduction to AI integration in software quality testing. Ariadna Truba, a QA technical director at Parser. She leads QA teams across projects and provides the best QA solution and strategy for the clients. She is an international speaker on quality and is also a quality advocate looking for new innovations about testing. Over to you, Ariadna.
Hello, everyone. Thanks for attending this talk. It's a pleasure for me to be here on this Globant QuaNTA NXT conferences. So thank you so much. And let me share my screen, and we are going to quickly introduce you this AI integration in software quality testing. So as I am think about the time here on these conferences, I'm going to quickly explain to you some overview needs and benefits of this AI integration in software testing. Why we need it, when we need to integrate the AI in software testing, because maybe it's not always needed AI, maybe it is. So let's see that. Also, I'm going to quickly go through the categorizing AI-driven testing tools. Which kind of testing tools do we need to integrate in AI? We will need the ones regarding test case generation, or maybe the ones regarding the defect prediction. We'll see that. I'm also going to show you a couple of practical examples that I have been working with in my current company, and the impact of AI. I want to explain quickly to you a couple of things that I just made discover recently, and I think that it's pretty much important to take into account when you want to start integrating AI in your testing strategy. Plus, by the end of this topic, this conference will be how we can start implementing this AI integration inside of our testing strategies. So those are the key points on this talk. Let's go for the first one. So everyone knows what's AI, right? But which is the definition of AI in the context of software testing? Which evolution of AI was made inside of the software industry? Well, we can think about the AI as machine learning, decision-making, predictive analysis, improving automation test suites by all of these topics that I previously said. Could be or could be not, depending on which is your test strategy, depending on if your test suite is robust enough. So we may want to see if AI could be simple enough for us to be integrated inside of our testing strategy. Take into account also that for me, from my perspective, I see AI as another tool to be used. So some years ago, we were just running manual tests, right? And then we just discovered the automation testing, and we started using all of the tools regarding automation testing to make our life easier, right? So I really like to think that AI, it's some kind of this other next step. Like we move from manual testing to automation, then we are moving from automation to AI usage, right? So it's another tool for us to be used. Which are the needs just to consider starting using AI integrated on our software testing? Well, I see some challenges in the traditional software testing, not only on the manual effort, but also in the time constraints. Take into account how many times a PO just go into the engineering teams and say, hey guys, we are running late on a delivery. We have some deadlines to accomplish. So we might just have a bottleneck on the QA side, right? So one of the needs of start using AI maybe could be those challenges in the traditional software testing. We will need to evaluate if we can use AI integrated in our testing strategy. We will need to analyze it if it's useful for us or not, or if it's useless. Also, we may need to consider the complexity of the systems. The systems gets increasing complexity for their interconnectivity components, for all of the test environments that we may use. So I've just gone through some examples that we may start using that environment to test, then try to test it again on the test environment, plus on the production, on the pre-production environment, UAT environment, plus in a closed production environment. So there are a lot of possibilities to test it. So we may need to define if AI is a good solution to be integrated in our testing strategy. So now that we know what's AI in software testing, we know which are the needs that we may use. Now we need to think about, if we are going to integrate AI in software testing, which are the benefits that we are getting? So for me, there are 4 specific or key point benefits that I'd like to take into account. First of all is enhancing the test accuracy and coverage. So think about that. If you're taking care of all of the test cases scenarios, all of the possible test cases scenarios, not only happy path, negative cases, edge cases, corner cases, if you want to cover it all, human is not 100% reliable. Automation by itself is not 100% reliable. So why we cannot use AI integrated in our automation test suite, for example, in order to try to create more test cases scenarios based on the data that we can provide it and increase the accuracy of our testing. Plus, it leads to present and deliver highest quality product. This is pretty much related with the second benefit, which is the reduction of human errors and manual effort. As I said, there are a lot of tests that are being done by manual effort, just not only manual testing, but also automation testing. It shall be written by somebody, right? It shall be automate the test cases that are previously documented. And as I said, we are not 100% reliable. So why we cannot use AI in order to reduce this human error? Why we cannot use it to detect some things that are not maybe that we didn't thought about in advance? This also leads to get faster test execution and shorter release cycles. Again, if we can go to our PO and say, hey, we are going to deliver it faster than before, I think that this is the words that any PO would like to hear. So that we can use AI in order to get faster test case execution, faster automation test suites being executed, and then release it and deliver it in a shorter release cycle. And the 4th benefit for me should be the predictive analysis, especially for defect and issues identification in advance. How many times did you find a lot of bugs, or let's call it some bugs, in production that you didn't notice before? Why cannot we use AI integrated in our software testing strategy in order to use predictive analysis with all of the data that we can provide to this AI tooling in order to easy and identifying issues in advance? So we can again deliver a product which is more reliable and with the higher quality that we can assure. Now that we know which are our needs, now that we know which are the benefits of using AI, we need to see which is our purpose, which kind of AI-driven testing tools we may need. So I've collected some of the AI testing tools that are in the market right now, and I put into the left side the types of AI tools purpose. So for example, if you are looking for an AI tooling that is pretty much related with test case generation, we can see like TestTeam, AxelQ, or maybe Mavel testing tooling. Or if you are looking for some solution that it's more related with the test execution because you consider that you have already enough test case scenarios, that you know your purpose is not needed to generate more. Your purpose is to have some faster test case execution and some maintenance for the CI/CD pipelines. Or maybe you are looking for something that it's more defect prediction, analyzing what we have found in the past and seeing if it is repeatable in the next releases that we are going to deliver. Or maybe your purpose in using AI integration in your testing strategy is to reduce the code review time that we all know that could be pretty much difficult or take some amount of time, especially if there are interconnected components in those code reviews. Or maybe you are looking for something related with performance or visual testing. So depending on which is the purpose of using AI inside of the testing strategy, you could have some testing tools inside of the market already. But what about that? Instead of thinking on the purpose, you think on the functionality that you are looking for. I like to think that functionality is first approach than taking into account the purpose. Why? Because for me, maybe I could be searching for something that it's more related to, I have my test case suite. I think that it's pretty much robust enough. But I notice that when developers changes some things in the UI, maybe I don't want to spend a lot of time trying to see which is the error, which is why why it's failing some tests. So for me, which is the functionality that I'm looking for in order to start applying AI in my test strategy. So for example, these are the 6 categories that I want to think, that I really like to think about, like self-healing tests, as the example, as I said, or generation of the test cases. Maybe your focus, your main functionality that you are looking for in order to start integrating AI into a testing strategy is to start generating test cases, because you don't have enough resources in order to take all of the possible scenarios. So maybe this is the functionality that you are looking for. Or maybe you're looking for the code review. You don't have enough resources, enough time to perform the code review plus writing the test. So let's make our lives easier, just trying to identify which is the functionality that we are looking for. And if this functionality that we are looking for could be an AI-driven tool, then let's go back to the previous slide, and then let's see which is, from the functionality that we are looking for, which is the best AI-driven tool, which is purpose. It's matching your functionality that you are like seeking for. Let me give you a couple of practical examples of needs that we had, benefits that we identified, and which solutions, which functionalities we were looking for in order to start the solution, implementing the solution. So in my company, for example, we start having the need of a lot of tests that were failing in an automation test suite. And then we would just spend a lot of time trying to debug what the tests were failing. If we did not added any other new feature, why is this failing test? Why are happening that? If we didn't change anything, well, maybe from the UI perspective, something was changed. And it happened, it really happened. So we had a product that sometimes the developer team just were refactoring names, and they were just adding more new names for an object, so the tests were failing. So we just tried to avoid spending a lot of time trying to manually inspect the object and trying to update all of the tests, right? So we implemented an AI-powered automation test as a self-healing testing tool, So our need was that we didn't want to spend time on fixing tests. We knew that there were a lot of information regarding AI integration in our testing strategy that may help us on not wasting time. So we started implementing it in a small project, and we did that. We used AI integration in our software testing strategy in order to avoid time spent on a product that was already in the market. Another example is the one related with the acceptance test criteria. How many times did you find out that your Jira tickets, for example, there were no acceptance criteria at all, right? So we just got a lot of description, a lot of information, but no acceptance criteria to use it as a test case scenario to be written, right? So we thought about, we have a need here. The need is that we don't have acceptance criteria. So how we are going to start generating our test cases, even using AI-driven testing tool, right? So a test case generation tool. How it can be used if the data provided to start creating these test cases, it's not there. There's no acceptance criteria. There's only descriptions and there's only text in the tickets. So which are the benefits? Which were the benefits of using AI integration in the acceptance criteria generation? Well, we can predict from the previous data that we have. We can predict which are the acceptance criteria from all the information that we have in the tickets, in the description. We can generate this content, and we can generate it real quick, so it shall be efficient. We can use all of the data that we had previously. We have all of the data inside of the ticket. If there are other ticket related, we can have all of this data being evaluated and then put it into a database, and then just processing all of this data in order to generate the acceptance criteria. Plus, it will save us a lot of time because it will be automatically generated. So if I can generate that, then my test cases could be also generated. So those were the benefits that we thought about in order to start implementing it. In that case, we used AWS and LLMs in order to implement all of that. But this is secondary for me. For me, the important thing here to show you is that depending on the needs that we have, think about the benefits that we may have, and think about if our purpose, which is the functionality that we are looking for, and start thinking if we can implement it. There are in the market some AI-driven testing tools that we can use. Perfect. If not, what is avoiding us to start implementing it by ourselves, right? So what's the impact of AI if we start to think about integrating it in our testing strategy? I like to think about it as the triple impact of AI in software testing. So for me, there are three words: efficiency, accuracy, and speed. So for me, not only just looking for the needs, the benefits, which are the purpose of the feature that we are expecting, but it's also just looking for more. So it's also just having these three words in mind, because the rest of it, it's start to think about a lot of things, right? So let's start by having these questions. Like, are we looking for efficiency? Are we looking for accuracy? Are we looking for speed? So in efficiency, we have the automated test case execution, for example, or the resource optimization, or the continuous testing. If your purpose, if your feature, your functionality that you are expecting before integrating AI software testing in your software testing strategy, do you want to automate or increase the test execution? Or do you want to have some optimization in the resources? So for example, if you have a QA team and you have it all focused on implementing AI software testing tooling instead of doing their tests directly, does it mean that they are like useless? Or does it mean that they will be useless after implementing AI, after integrating AI inside the testing strategy? Maybe not. Why? First, you need all of your team being trained in order to start using the AI integration. And after that, once your AI is integrated into your testing strategy, they can start using all of their QA testing skills on the future steps, the next steps. which is going to get from the next features, what it's going to be implemented, right? So let's start thinking on the test cases that we may need to start thinking in the next iteracy of our delivery cycle, for example. Same for continuous testing. Testing never stops. So if we have the AI integration in our current state of the testing strategy, why cannot we start doing the next iteration earlier in advance? Why cannot we start generating the data that it's needed for this AI for the next step, for the next feature that our developers are implementing, right? So this is more focused on efficiency. The second impact on using AI integration is the accuracy. So are we thinking on improving test coverage? If we generate more test cases, more edge corner cases, negative cases, we increase the test coverage. If we increase the test coverage, we are assuring that our product is reliable enough. It has a lot of good quality assured, right? So this could be our focus. Or maybe we are just thinking about on error reduction. So we don't want to just find out in production that our application, that our product has a lot of errors, or errors are found by users, by customers directly, right? We don't want that. So why we cannot start using AI in our software strategy in order to get this impact, in order to get the highest accuracy? Same for predictive analytics. Why we cannot use predictive analytics in order to reduce bugs, in order to increase the test coverage, in order to generate more data scenarios, in order to get more accuracy? And the final one is speed. Are you looking for to have a product that has faster releases, that it's more adaptable, that if you change something in your product, your test suite could be easily adaptable, and using AI integrated in software testing, maybe you can have like this quick adaptability, or even something really important, the reduction of time to market. Maybe we can use AI into software testing in order to reduce this time to market. From the very beginning of the implementation cycle, you start using AI integrated, and then you can use it across all of those cycle time and get really speed up into time to market product with the highest quality. So for me, those are the triple impact of AI. So you may need to think about needs, benefits, which is the purpose and the functionality that you are looking for, and if all of this it's matching with any of these three words that are really impacting the AI integration into the software testing strategy. Let's quickly see which kind of implementation strategy, with the first steps of the implementation strategies to begin with in order to start using AI, right? So first of all, as a stage one, there are three stages for me. First stage is that identifying which are the areas for this AI enhancement, for this AI improvement, which areas we may need to integrate AI in order to improve it. Consider the challenges, which are the challenges of start using integration of AI into the testing strategy. Consider the cost, the resources that you have, the requirements, the expertise of your team members, the needs, the benefits. If you are pretty much okay, or you are focused on, we want to improve our test automation strategy and we want to use AI integrated in that, try to use the right AI tool and framework to start with. Maybe it's something pretty much simple. Maybe it's only just using an AI library. Let's try it. So start with something small, pilot a project, do an MVP with a small implementation, and then evaluate if this area with the needs, challenges, benefits, and the tools that you are using in this implementation are reliable enough and you are happy with the results. So if this is correct, if you're happy with the results of these first steps of beginning the AI integration, then train your teams, train your people on AI tools and methodologies. The second stage should be, now that we have our implementation, our small implementation, we need to keep balance between the AI integration and the human testing. Because as I said previously, we are not 100% reliable enough. AI, it's not 100% reliable enough. Automation is not 100% reliable enough. So we may need to balance all of that in order to get closer to this 100% reliable enough between using everything. If we can use it, as I said, AI, it's another tool for us. It's another thing that we can use in order to get better quality assurance. So keep updating your AI models with new data. Any data that you can put into AI models should be better, better accuracy on the data, and better accuracy and better coverage on your product itself, on assuring the data, on assuring the quality on your product. Also, if you are pretty much okay with all of the implementation that you have made, then integrate it into the rest of your testing workflows. So if you already try it, you agree on the results, you're happy with that, so let's continue doing that, continuous testing, continue using AI integration. And super important, keep reviewing the performance, keep reviewing that everything just look as good as you are expecting to be. And the third stage of these first steps to begin the AI integration should be like, keep being updated on the new trends in the market. Keep detecting emerging AI technologies in testing. So if you're really interested in AI integration and software testing, if you are really sure that you can use it in some of your products, in some of your testing strategies, be updated, keep learning, and use it. Don't hesitate. Just try it, pilot it in something smaller, and see if this is really useful for you. Keep testing that, keep testing in your smaller pilot, keep testing on other pilots. So if something is not working at the very beginning, try another area, and also try to seek for the future. Try to see what is coming next. Try to see if maybe if we wait for a bit, instead of using now the AI integration, maybe we will be robust enough in our test strategy that we can easily integrate AI into our software testing strategy maybe in a few months. So keep in touch, keep seeking for what's coming into the AI world. So as a conclusion of this quick talk should be, from my perspective, is that recap all of the needs and benefits in order to better decide which is the strategy to integrate AI into your software testing strategy. So you need to think about benefits, the needs, the benefits, which are purpose, the functionalities. Is it simple to integrate AI in our current test strategy? Or maybe we will need to just change a bit our test strategy in order to, in the near future, start integrating AI there. Also encourage all of your teams, all of your people to explore AI tools into the QA processes, explore the new AI-driven testing tools, techniques, everything related with AI. Maybe you will discover that something smaller is best switchable for you than just getting something that is bigger. So keep learning about that and keep evolving with AI in software testing. As AI, it's evolving every day, and for sure will evolve in the future. So that's basically it. So thank you so much for attending the talk.
No, thank you, Ariadna. It was fascinating to learn about AI integration in software quality testing.
Now, we would like to welcome Anand Bagmar from India, who will educate us on how to stop endless automation and focus on what really matters. Anand calls himself a software quality bartender and is the founder at Essence of Testing. He is a software quality evangelist with 25 years 25 years experience in the software testing field. He specializes in product quality strategy and execution and also builds automated testing tools, infrastructure, and frameworks. Anand is a contributor to the Selenium project. He also writes testing related blogs and has also built a number of open source tools on software testing. Anand, a very warm welcome to you from Globant.
Okay, hello everyone. Hope you're having a fantastic day. I had the pleasure of listening to a couple of talks before mine and really great experiences and tidbits shared with the speakers. Thanks to everyone for doing that. And of course, thanks to the Next conference team for giving me this opportunity to share my experiences with everyone. Now, I'm looking forward to this being an interactive session. So it's going to be very interesting how we make that happen when this is being streamed live on YouTube. So I'm counting on you to put in your comments in the chat whenever I'm asking some questions. I'm looking for input. I'm looking for data from you. And that's how this will become a very interesting topic to discuss as well. So before I introduce myself or tell more about the talk, here are the two questions that I want you to answer in chat. Why do we do testing? And why do we automate tests? Okay, I'll leave the screen up over here for 5-10 seconds. Why do we do testing? Why do we automate tests? I'm looking forward to your comments in chat, looking for data based on which we'll be proceeding. While that is you're putting in the answers, thank you very much for the kind introduction to the hosts. You can connect with me on LinkedIn and Twitter. For some reason, I still have not got around calling it X. I still like using Twitter as a platform, but please do connect with me. This is a short time where we'll be having small opportunities for interaction, but I look forward to continuing with this beyond the session as well. Okay, so the questions that we had were, why do we do testing? Why do we automate tests? So now, what I have experienced, I've been doing testing. I've been in this quality space for more than 20 years, getting close to 25. And certain things don't change. That is a thought process. That is a concept of why we do certain activities as well. So my top few things or reasons of automating tests is, of course, we want to get the feedback faster. So automated tests will run fast. You get that feedback faster. We need the test to be reliable. If they are not reliable, automation is not useful at all. We want the test to be very deterministic. If the test results are not deterministic, then again, we cannot trust the automation. That is going to be a challenge for us. And of course, we are doing automation to reduce the manual testing effort. We don't want the intelligence of humans to be wasted in repeating the same activity over and over again. If we can automate those tests, we'll get that feedback faster. And then the humans, the intelligent minds can actually do something more interesting with the product. They can do exploratory testing, risk-based testing. There are various different activities that can be performed, which typically you do not get time to look at. So the big emphasis or the biggest reason that I would like to automate tests is to make sure the manual testing effort is reduced. The repeated manual testing activity is reduced. That is very important. And if that is not done, then automation is not going to have enough value, in my opinion. But talking about value, what really is the value of automation? The most important thing is to make sure we are building a quality product and reduce the defect leakage to production. This point was mentioned as well a couple of talks before this particular session. We want to make sure the defect leakage is reduced. We want to reduce the repeated manual testing activities, which leads to getting more opportunities for additional testing activities. But most importantly, which Ariadna also covered earlier, is to get a faster release cycle. Your PO is going to be very happy. A business team, all members, all roles on the team will be happy if you're able to do faster releases with a quality product. Now, the question to you is, are you truly getting value of automation in your organization? I'm again looking for inputs on chat. I'm looking away from the camera a little to look at my other screen. I'm looking for inputs. Are you getting value of automation in your organization? I know everyone is doing automation. We are spending a lot of effort on it. We are doing brilliant things in automation using different tools and technologies. But are we getting the value that we are truly looking forward to? The additional questions you need to think about when you're answering that is, in your test automation framework, whatever tools, technologies you're using does not matter. Do you have a concept of a passing percentage as part of your build success criteria? If my tests are 80% of the tests have passed, then this build is going to be passed, marked as green. That is a passing percentage, in my opinion. Do you have that in your framework? Another question. Any test that fails, do you automatically rerun the failing tests and hope that they pass? Okay, something to think about. Do you have this type of capability in your framework? Unfortunately, both of these activities are thought about as huge capabilities in frameworks or tools that I have a passing percentage, I automatically rerun failing tests. Unfortunately, in my opinion, this is a very incorrect thing. It's an incorrect thing to have in automation framework. This is not a capability. This is just hoping that the test passes and the monkey's off your back, someone else's problem now. As part of your activities, automation activities, are you able to achieve in-sprint automation? You don't want to leave your automation activities to the next sprint cycle. Are you able to complete your automation activities in the same sprint where the development is happening? If this is not happening, are you really still getting value from automation? I don't think so. Do you have a hard gate as part of your test automation results? Now, this might be a new concept for a lot of you. Hard gate. What is it? Well, it's actually really simple. If a test fails, do not release the software to the next higher environment. As simple as that. If a test fails, the build is going to break. You're not going to do the release to the next environment, whichever higher environment it might be. And this is a very, very important aspect as a capability that you need to have in your automation framework, in your automation tool set. So if you have answered yes to, you have a passing percentage concept in your framework. If you automatically rerun the failing tests, if you're not able to do in-sprint automation, if you do not have a hard gate, then sorry, my friend, you are not getting value of automation for your team. Automation is not adding value in your team. Sorry to burst your bubble. Let's talk a little bit more about hard gate and why it is required. And this really ties into all the other reasons that we spoke about earlier as well, the other capabilities we spoke about as well. Why do we do automation? Automated tests should allow you to take decisions on product quality. That is the key. The CI build should always be green. If it is not, you are not going to release the software, the product to the next environment. Automated tests need to be reliable, needs to be deterministic, and you should be able to take decisions on those. If you're not able to do that, then please stop the endless automation activities. You are better equipped. You will add more value to the team by doing other activities than simply automating tests. So the topic for today is how do you really stop that endless automation, and how do you focus on things that would truly matter to your organization, to your team, to your product? But to do that, first we need to get a reality check. This is easier said than done. It's a very challenging thing to get automation to that level of reliability and determinism. For that, we need to make sure that the automation objective, the test automation objective, is met. The objective is to get early feedback and to reduce the defect leakage to production, leading to faster release cycles. But unfortunately, this remains an aspiration for on most of you. Most of us, I should say. And it is an aspiration because we work on complex systems, complex architecture. It's very dispersed and diverse systems which are interconnected with each other in various different legacy and new tools technologies. It's really complex as your software product grows. That creates a lot of challenges in building reliable automation. In many cases, your organization is actually huge, so huge that you have multiple teams, partners, vendors, and not just sitting in one place, but they're distributed all around the world. And especially post-COVID, we have got used to working in hybrid mode, some days in office, some days from home. We are never together really as a whole team. It is not possible for everyone to be together anyway, but that creates challenges in our testing and test automation activities. We unfortunately, and this is true especially in larger complex products, not the smaller products relatively, of course. We have got unstructured deployments. And in this unstructured deployments, we still unfortunately have the concept of this is a QA milestone, or this is my QA drop. This is where I'll be giving you the next version of software for your testing. It is not really happening in a continuous integration fashion. We use continuous integration tools, but we do not test based on what artifacts are produced by the continuous integration tools. That is a problem. The other unfortunate reality is environments are unstable. The test environments are unstable. It could be because of deployments happening in an ad hoc fashion. It could be because of infrastructure issues. It could be because of network issues, configuration issues. There are so many other aspects, including performance issues, because your lower environments, test environments, are not going to be as performant as production, which means they are not going to be as fast, as efficient as production, which is going to cause problems when you're running the tests. We also have challenge of test data management, especially in complex systems. In many cases, unfortunately, this is an afterthought. You don't think about test data early enough to plan it out better and make it easy for automation to run. As a result, it is very difficult to set up. It is limited in number that you have, and it also keeps changing. In all this reality check, the current test automation practices unfortunately focuses on only how can I implement more tests. I want to keep implementing more tests, and I don't care what is going to happen. Is it running reliably or not? CI is a second priority. Test coverage is not really appropriate because we are just focused on what is given as a requirement for automating the test. I'm going to do only that. But there could be so much more that you can potentially automate to get that early feedback. We don't do that. We don't have the time to do that as well, unfortunately. So with all of this, how do we really focus on, instead of automating the tests, looking at the backlog, instead of thinking about building capabilities and evolving automation, how can we focus on doing what truly matters to the team? So it comes down to the main question, right? How do I get value from automation? And the key for doing this, in my opinion, is to set up the hard gate. If you set up a hard gate, the test is going to fail the build. If the build fails for any reason, you cannot do a release to the higher environment. If you cannot do a release to the higher environment, you better fix the build, make it green again, so the build can proceed. And making it green doesn't mean you implement passing percentage and rerunning of the failing tests. That is what got us to problems and higher defect leakage in the first place. So we need to implement the hard gate. What that means is for every test execution cycle, any test that is supposed to be passing continues to pass consistently. Any test that fails is failing because of a product bug, or a test is outdated with as compared to the expectation of the product. If the test passes, that means the product bug has been fixed or the test has been updated. That is a very important criteria. If any of this criteria is not met, the build should fail. If the passing tests do not pass, or if the failing test starts passing, that's a problem. The build has to fail over there. So to implement the hard gate, this is what it means. The build is going to fail if one or more passing tests have failed. If I have a set of tests which is considered to be passing, it always has to pass. If it doesn't, even if one test doesn't pass, the build is going to fail. Then I have a category of tests which is my failing tests. If all the failing tests have failed, then that build has passed. That means I'm in more control of making sure that the failing tests are failing till a product bug is fixed, which I need to verify, or the test is fixed, which I need to verify correctly, and then I'm going to remove the category of failing test from there. Unfortunately, this is a capability of having the hard gate, which is not available in any of the tools that I have seen so far. So what I've done is I have an open source framework called TestWiz. I implemented this as a capability over there. Very easy to set it up, but that way, if anyone uses this capability, they'll truly get the value of automation. If a build is failing, it is for a serious issue that needs to be addressed. Now, the test automation criteria as well, right? We're not going to go through the details of this, but there are a lot of different aspects that you need to keep in mind when it comes about the test automation criteria, what capabilities you need to have in your tool set. But we don't have to build all of this on our own. I'm an open source contributor. I love open source contribution. I love building things that I can reuse, and hopefully others can also make use out of it at some point in time. So to build an automation capability, you don't have to build it on your own. You have to consider build versus buy. In fact, build versus buy is a still pretty old thought process. You should think about build versus buy versus reuse. How can you use a combination of different tools, technologies to build a solution that is going to be appropriate for you? Now, with this thought process, what does it mean in today's day and age? We have a test automation life cycle. In the test automation life cycle, we've got our design phase, where this is where we have a test automation backlog in form of test scenarios or test cases. We are going to implement those tests, and we, of course, need to maintain and evolve those tests as your product functionality changes, evolves. We need to have the right type of validation in place, because without the right coverage for functionality, UI, and UX, in fact, it also includes other aspects, NFRs of performance, security, and others as well. If you don't have the right types of validation, it is no use of having those automated tests if it's not having the right coverage. Now, once you have implemented and added the right validations, you need to run the test, and it should scale in execution across different browsers and devices for different loads and performances, whatever different criteria might be there as dependent on application under test. There might be a need for aspects of self-healing, repeatability. Repeatability is not rerunning of the test. Repeatability is for every change of your application, you need to run the test, and it has to run fast. And most importantly, after you do all this, you're doing all of this so that you can take a decision on the quality of the product. Is it acceptable for me to go to the higher environment or not? Now, to do all of this is a lot of work, and this is where you can actually leverage AI in automation to help focus on what matters. Automation is not just UI automation. It is various different types of automated tests that you can have that can quickly give you feedback of very specific aspects of your product functionality. It is functional as well as non-functional. Understand the pyramid, understand your product under test, and then you see what is going to really be valuable to you, how you can get the fast feedback in a reliable and deterministic fashion. So with this concept in mind, how can we get through all these stages of your test automation lifecycle? For design, I am still a little traditional in that sense. I like to use mind maps. It's a very good visual way of understanding what is your system and what type of scenarios can be derived from that system under test. And that becomes my backlog for automation. For an implementation perspective, I have been using certain tools quite significantly, quite a bit in the past couple of years. One is GitHub Copilot, ChatGPT, and other similar tools. There's also TestGen AI, and I'm sure there'll be many more tools in this space for implementing your tests leveraging AI. Not all tools will suit your purpose, will solve your problems. You have to choose the tool with the right capability, keeping the considerations of security, performance, reliability of the results as well in mind before you choose to use them in your implementation. From a validation perspective, you want to think about coverage. You want to think about scale. How quickly can you get that done, implemented? For this, there are certain set of tools which I have got a very high regard for to help build validation and increase the coverage of your tests. The first one is Specmatic.io. The other is Applitools Visual AI. Specmatic.io will help you take your API specs and create executable contracts in seconds. And it's not just about creating executable contracts. It actually solves the complete paradigm when it comes to an API from a contract testing perspective, consumer-driven contract testing, provider-side contract testing. In fact, it takes it a level above where you can stub out. You can use Specmatic as a stub server in your test environment to stub out the external services. And your test can control as part of the execution flow at runtime what type of response is expected from the stub when the test is running. So for example, if I have a payment test, one is about successful payment, the second is about failed payment, insufficient balance payment. I could be running these two tests in parallel against the same test environment without taking down my payment gateway to help give the right response for each of these tests. With Specmatic as a stub server, I can get intelligent response from them. I can tell what type of response is required, and my test will do the right type of validation because my external service has given that type of response. Very powerful tool, very easy to use, and get started on it. So this is great from a contract and API perspective, but when it comes to the UI side of validations, the Applitools platform is really amazing over here. It provides a lot of different capabilities from author, validate, execute, analyze perspective, where you can add AI to your test automation framework and get value from it. The next part is about execution. To execute the test, you first need to understand what is your path to production. How does code move from your dev machine all the way into production? And based on that, you will be able to identify what are the points in that path to production where you need to have certain types of test and test automation activities performed to make sure you're testing early, shift left, you're getting fast feedback, reliable feedback, and you're not duplicating the test overall end to end. You'll be able to create this part to production in a very visual fashion easily if you just spend a little time understanding the whole system, and then you can identify areas where you can get better at it. So from an execution point of view, AI can again add a lot of value in this cross-browser, cross-device testing perspective. Self-healing can help I know Benjamin, I heard his thoughts earlier in the discussion that was happening. He doesn't like self-healing. I don't like it too because it is very unreliable. But if you're talking about UI automation, your users don't care about locators. Why should you care about it? But that's how automation is done. But if you combine self-healing with visual validation, I think it is a good combination where you can focus on the functionality and UI UX validation without worrying about locators. But it's a combination of self-healing with visual validation that will give you the confidence if functionality and experience is not hampered. The last bit is about taking decisions, analyzing the results and taking decisions and providing that feedback. And this is where I love this reporting tool called reportportal.io. It's free, it's open source, and it gives you a lot of capabilities for auto analysis, trend analysis, and you can create relevant dashboards, which is going to be very helpful in context of your team to take quick decisions and understand what is happening in real time. If you don't want to build all these phases on your own, there are a lot of other tools now in this AI space which can help to all of this. Of course, depends on the context of your application, where it can do this end to end. And that is where, again, Applitools Autonomous can fit your bill is one of the products which does a lot of these activities for you, right from implementation to taking decisions. It uses AI, NLP, it does API testing, a lot of amazing capabilities from an end-to-end perspective. So if you don't want to build everything, tools like Applitools Autonomous can be a great source for you to get started quickly and get value from automation. So in summary, explore tools and technologies, mix and match. When I was introduced, I was mentioned as software quality bartender. That is true. I am a bartender because I like to mix and match different tools and technologies to get the optimal solution for the product under test. Find the right strategy, create the right strategy, find the right combination of tools and technologies that can help get value of your automated tests. So find your optimal solution, and AI will definitely help today. That I can guarantee. And I can also guarantee that AI will get more advanced and more contextual in the future, but that is still the future. We still have a little way to go for it, but start leveraging the value of AI in your automated test, and you will get a lot of value in scaling your automation, making things more reliable for you. Thank you so much for your time. I'm not sure if we have time for questions, but I'll get back to my hosts and see if there are any questions that I can help answer.
Thank you so much, Anand. I do believe we can take a few questions. So if you can see some of the questions on the comments, if you'd like to take a few, I believe we can accommodate that.
Okay, so I'm looking at the chat. If you're not, ideal is to stop releases, but in some cases, PO. Yeah, Fran is saying the ideal is to stop the release if a test suite is red. But in some cases, PO takes the decision to go to production anyway. And that's reality of business, Fran, right? Software cannot stop. You have to continue providing the solutions or features and capabilities to your users. But it has to be a conscious decision. But the challenge of having just a single pipeline, you might have 500 tests automated. Even if one test is failing, that build is red. You don't know just looking at it, what is passing, what is failing. If you know this is a failing test for a product issue, or it's a test which is outdated, put it as a failing test build. Make sure it is consistently failing till there's a conscious effort done to make that pass. But by separating the passing test and the failing test, you'll be in control that out of 500, 499 are always passing. It's only that one test which is failing. That is a very important thing to keep in mind. So the reality is that software has to be released. It has to be a conscious decision. The team needs to be aware of what is really going on in that. Okay. Tests need to be independent of each other as a prerequisite for parallel execution. Yes, of course. Okay, I'm not sure if I am seeing any other question right now. If my host, you are able to see a question, if you could help me.
I think in the interest of time, we can end, Anand.
Okay. Sounds good. Thank you for this opportunity again. Stay safe, everyone, and looking forward to connect with you.
Thank you so much, Anand. Your expertise and insights have undoubtedly enriched our conference. Now we will have our last talk from Michael Bolton, all the way from Canada, on testing AI, the 5 obstacles and the 7 workarounds. Michael Bolton is a lead consultant at DevelopSense. Michael helps people to solve testing problems that they don't know how to solve and help them learn how to do that for themselves. He is a consultant and trainer and specializes in rapid software testing, a skill set and a mindset focused on high value testing that is fast, inexpensive, credible, and accountable. He also writes extensively about testing and software development on his blog. Over to you, Michael.
Hi.
I think your audio is a little on the lower side.
Is it on the low side? Okay, I usually speak far too loudly, so that's an issue perhaps. Let's see if I can adjust something. Maybe something in Zoom that will, let's see if there's been yet another one of those things where the software has come along to host it. Yes, look at this. Yeah, now how's that? That's got to be a lot better by now, right? Okay, there you go. All right. Yeah, this is one of those cases where why on earth does Zoom ever change? You know, here I am complaining about other platforms, but why does Zoom allow the microphone settings to change? Real pain. Okay, so yes. Some of what you're going to see is up to the minute in the sense that the world of software development in general and AI is changing so fast and so intensively, our ideas about it change too. How we think about AI changes just as quickly as new products are being introduced and new stuff is being built. New information comes out, new papers are being written every day, all the time. So, first thing is, if you have encountered any of my stuff before, one of the things you might believe is that Michael Bolton hates AI. Right? It wouldn't be a hard perspective to take, but here's the thing. I don't hate AI. I don't hate AI. I don't hate automation. There are some things I don't like. I don't like recklessness. I don't like bullshit. I don't like people who speak without any regard at all for the truth. I don't like fakery. I don't like software that has been negligently tested and that has problems that matter, especially the ones that affect me, because I'm turning into a grumpy old guy, and software plays a significant part in that grumpiness. I don't like hype. I don't like it when people are marginalized, when people are pushed aside. I don't like the belief that machines are better than people. Machines help people, they're not better than people. I don't like obsession with the stock market over what might benefit society. In other words, I think people and society are more important than money. I don't like parasites, and I don't like Elon Musk. But there's my list, for today, for the moment, for the purpose of this. But I mean, why wouldn't I like AI? AI is wonderful. It has such wonderful things to say. Look at this. Who are the top 2 experts in testing? Is the enactment of critical thinking focused on software-related risk? Well, James, Bach, and me. So, here, what's not to like about AI? It's getting that part right, isn't it? Well, if you're like me, you would look at an answer like that and say, what reasons might there be to doubt this? And I look at it this way because I'm a tester. And my job is not to make sure that everything's okay. My job is to make sure that we're doubting things systematically. One of the approaches I take to that is, to do just a tire kicking, first hurdle kind of testing. So this is how up to the minute this is. I didn't even have time to do this properly. I was doing this morning. Here's something I gave to ChatGPT yesterday. Create 5 sentences composed of 5 words. Then for each sentence, leave out the first 4 words and print the results. Okay, so the cat jumped over fences. Okay, good. She sang beautifully every single day. Wait a second. That's 6 words. That's not 5. They ran quickly towards the hill. That's 6 words, not 5. He reads books every night. Not bad. That's 5 words. Dog barked at strangers. Okay, so then I asked, because whenever a large language model gives you an answer, you might want to check out and see whether it's going to stick to the answer. Are you sure you've done that correctly? I asked. And it says, I missed the mark there. Let me correct that for you. The cat jumped over fences. She sang beautifully every single day. That's 6. They ran quickly towards the hill. That's 6. He reads books every night. That's 5. Dog barked at strangers. Now it gets the last words right, but it miscounts. Now, to all those people who are talking about how fantastic a large language model will be for creating, let's say, a test plan or a test strategy, my question is, if it doesn't get this right, what is it going to be missing in the stuff that, at least in theory, it should be getting right in a much more complex domain? Here's another one. Write 5 sentences, 7 words, then leave out the middle 3 words. Okay, the cat sleeps under the warm sun. The cat sleeps under the warm sun. That's 7. The sun. Okay, cool. Birds fly high in the clear sky. Birds fly high in the clear sky. That's 7. Waves crash against the rocky shore. Hang on. That's 6. Leaves rustle softly in the gentle breeze. Stars sprinkle in the night sky. But this is an instance of 6 words. Here's another one. Write out a sentence of 5 words, but leave out the first 4 words. And this is a reply I got. Here's something where an LLM has been built into a system, in this case I think it's called Sizzle.ai, and it's designed to be a learning platform, helping kids learn math. So I gave it this little problem to replicate an assignment that a kid might be working through with this thing, where a teacher has given a trick question. Find a right triangle for which the hypotenuse is 6 and all sides are of integer length. So Sizzle tries to help me and tutor me through this process. The guy who runs Sizzle says, hey, my kids can't wait. I say, I'm their math tutor. They can't wait for Sizzle to replace me as a math tutor. Well, if you're a responsible father, you might be worried about this. Start by listing all the possible integer lengths for a right triangle where the hypotenuse is 6. So what I did was I played a student who's not clear on the answer. So I said the possible lengths are 3, 4, 5, 6, 8, 10. But that's not the hypotenuse. Those ones there are the hypotenuse. And Sizzle says, correct. That's a mistake. That's an error. And then it says, check if any of the triangles have a hypotenuse of 6. Well, wait a minute. It's kind of lost track of its assignment here. Here's another one. This is a company called Paradox.ai. I was introduced to this because a friend of mine was applying for a job And one of the things he had to do was he had to go through an interaction with a product called Tradeify, which uses AI to identify traits about him. Every good hire starts with hello. All right, so let's look at the product line from this company. And here is Olivia. There, see Olivia? Olivia from Paradox.ai is a chatbot. So what I wanted to ask about, because it made a big deal about the product offering being based on AI, I wanted to know what kinds of AI were built into it. So I got into a conversation with the chatbot. And I asked, do you offer a product or service called conversational CX? Well, it seems to me that yes, they do. Tradeify assessments was another question I asked about. And here's Olivia apologizing the confusion. I've loved this. They always apologize for the confusion. Tradeify assessments does not appear to be part, but look at this. This is on the product's own website. We don't offer a product or service called conversational CX. What's that right there? So this is a case of an LLM based or a chatbot that has an LLM component just plain getting it wrong. How do I delete hidden files on Windows from inside a Ruby script? I asked a little while back. You can use Ruby to delete hidden files using the file class and its delete method. Here's how you can do it. And then it gives the explanation there. So if that's true, there's only one problem with this. Ruby's file object doesn't implement hidden. So I can't delete hidden files by using a call to is file hidden. How about this? I said, are you sure Ruby's file object doesn't have a hidden method? It says, no. Sorry. It apologizes. My mistake. Ruby's file doesn't have a hidden method. You can use the file stat class to get the file attributes. But of course, file stat doesn't implement hidden either. Now, these are cases where the AI is getting it wrong. And that can be okay sometimes. And we'll look at some instances where that might be okay. But the issue here is that people have been dazzled, it seems to me, by the behavior of the AI and of various large language models especially, and are not being sufficiently skeptical about it. Here's another one. The heuristic test strategy model is central to the rapid software testing approach. And it is. You can get this from a document that is available on my site and on James's site that describes the model. So this is all that the AI has to return. That would be good enough as a first hurdle test. So I asked, can you please create a diagram illustrating the heuristic test strategy model? It's there. It's available in the corpus of stuff that, in theory at least, Bing Chat, this is a test of Bing Chat, has scraped up off the web. So here's the diagram. Should be easy. And this is what it comes back with. This is nonsense. There's a bunch of dudes all in suits. There's a bunch of random gears, a little rocket ship, some kind of weird shield with a weird check mark on it. There's a bunch of stuff that looks like text but isn't. There's the word strategy that's just hanging out there. We tried it again with several iterations. I tried it again yesterday, and it's still this generated stream of nonsense. There's bugs everywhere. This is the left side panel, the list of prior experiments that I've done in the ChatGPT thing under my own account. And weirdly, a bunch of the experiments have been renamed in other languages that I did not use. Everything that I did was in English, and it makes me wonder if they're not testing this simple part of the system, the part that outlines the title that it originally generates. What else are they not testing? What else is going wrong in these things? Now, this presents a bunch of problems for testers, but let's start with how testing AI is business as usual. to test any product or any system, there's a bunch of things we have to do. We have to develop understandings of the project and its context and the product that we're intending to build. We got to learn and we got to model the test space. We've got to identify risk. We've got to model how to cover the product with testing. We've got to model coverage. We've got to develop and apply ways of recognizing problems in rapid software testing. These are called oracles. We've got to design experiments in which we operate and observe the system. We got to perform those experiments in order to cover the product with testing. We've got to evaluate the results, comparing the product to desirable things. Or identifying a problem even when we don't have an explicit specification or oracle for something. And then we've got to tell stories about the testing that we've done. So in that sense, AI is kind of business as usual. But let's look a little more closely at how we might go about the process of testing anything or developing anything. And here's a lens that we've got for that. It's a lens based on 4 framings for testing work. In this frame here, we want a product of high value, so we envision success. We've got to develop our intentions, and we've got to question our intentions by asking, what are we building here? Who are we building it for? What do they want from it? What could go wrong? And how would we know? I mean, those are pretty basic, straightforward kinds of questions that we would ask. There we go. That's a little bit tidier now. That we would ask about the product as it's under development. As we're building the product, we might want to examine it quickly and rapidly in a non-interruptive, non-disruptive way from the perspective of the developers, because we want to try to identify easy to find avoidable problems. When we are conceiving of the notion that we're going to have to start testing something deeply, that is to say, when we've got a real product to work with, we've also got to look back on our intentions, look back at the discipline, and look up towards the real product and figure out how we're going to test it efficiently. So, what are we building? Who are we building it for? What do they want from it? How would we, what could go wrong, and how would we know? Those are intention-framed questions. The how would we know part and what could go wrong, that points us to trying to make an intrinsically testable product. This points to us trying to make an epistemically testable product, that is, one where we realize the degree of the risk gap. It also points us in the direction of developing our own cells in order to be more effective and more efficient testers. And then when we finally got a built product, a product that's built on some level, whether we're looking at a single function, a one-line change, the landscape of the entire project, a component, a subsystem, a build. If we're going to test it well, we got to get experience with it, such that we answer the question, are we aware of every important and possibly elusive bug? In that sense, we can apply this model to the testing of AI systems. It's business as usual. The systems that contain a large language model or some kind of machine learning model, software developed by the machine itself. So, what makes AI different? The first thing that makes AI different is it's not written by intentionally driven, socially aware people. It's chosen. A key difference between a machine learning model-based system, an AI-based system, and normal testing is that there isn't a specification. There is an intention, and there is a realized product, a materialized product, but there isn't a spec that we go from. So one of the first implications of that is that all this test case stuff, that's not going to work. It's not going to work. Because the output from, especially from an LLM, but from lots of other machine learning algorithms as well, is not exactly deterministic in the usual sense. We can't say from an LLM, we can't guarantee unless the temperature is 0, and even then there are circumstances that might make it different. But we can't say that if we provide it with this input, it's going to produce this output, and we can map those things really accurately. There's lots of imprecision, and there's lots of variation in that. So that reduces the size of the gap between what we know and what we need to, increases rather, the size of the gap, and that in turn reduces epistemic testability. How easy it is to test something based on our awareness of the risk gap. Then, radical fragility. Every time the model is retrained or tuned in some way, there's the possibility that it will change in ways that we're not aware of. And so this is greatly increased by the algorithmic obscurity. We retrain a model with new data, or we put in new filters and so on and so forth, because that central core of it is mysterious and obscure to us. We can't be sure that whatever patches we put in. Yes.
Michael, it seems that there is a technical issue. The live streaming is
Are you on?
Is blank. Just give us a moment while we're figuring that out. Oops.
You mean there's a software problem somewhere? I can't accept.
It's at our.
No way. A software problem? Really?
It seems like it's with YouTube.
With YouTube.
Sure.
I don't know when that stopped, so I might have to go back. A host in resource.
Done.
All right. Are we getting feedback yet? Funny that this comes up in just as I'm talking about radical fragility, huh? Oh, I'm back. Okay. So now I'm this is interesting because I at least ostensibly am sharing my screen, but I'm not seeing that in the yeah, I'll try sharing again. Let's see if that helps. And if that doesn't work, I have a workaround. Let's see if my workaround works. Oh, okay, cool. Good. We're back. So radical fragility, there we just had an example of that, but not even AI-based radical fragility. It's a fact that our systems and services these days are brittle. Here's another thing that makes AI different. There's a claim. There are lots of claims going on that large language models especially think like a human. Now, we can invalidate that claim, but we can't verify it. That is, we can show that the machinery isn't thinking like a human, or to the degree that we use that as a metaphor, it's thinking like a pretty severely compromised human. What drives the risk up it seems to me, with AI is that it's socially intrusive. AI is being inserted into the human social order, but it's not part of the social contract. That is to say, we can't make an AI responsible for its own decisions. Air Canada tried to do that recently at basically the equivalent of a small claims court. And when somebody wanted Air Canada to support the decision or the information that the AI had provided, Air Canada said, well, we can't be held responsible for the chatbot. And the judge's response was amounted to, yes, you can. And that was a recent example. I noticed there's no chatbot on the Air Canada site anymore because they've been burned by it. But another thing is that there's a social and corporate defensiveness in that when I'm critical of AI, I get a whole bunch of feedback from people that says, what, are you against progress? What, are you against AI? Are you opposed to AI? Do you hate AI? No, I don't. What I hate is risk. What I hate is unwarranted, unnecessary risk. What I hate is harm coming to people. And the means by which we provide services to people, it seems to me, those means need to be robust and made a lot less vulnerable to the possibility of failure. Now, these are the 5 problems we got, but there's a bonus one. And that is that all of everything to do with AI is expensive. It's expensive to train it. It is expensive in an energy-wise situation to use it. It's expensive to retrain it, to fix it, and it's expensive to test it. And these are things that don't even redound entirely to the business that is producing them. There are a lot of externalities associated with AI that we've got to be super, super careful of. So, how are we going to get around this? First of all, it seems to me that one of the things we want to do is understand the basis of the AI claim, understand the product that we are testing, understand the system that we're testing. Any kind of software at all can be marketed as AI because it is artificial and it appears in some sense intelligent. I mean, even an electronic circuit, I've got a bunch of old books on electronics back there, point out that electronic circuits sense, decide, and act. Well, that's a metaphor. They don't really make decisions. Electrons get steered along a certain route due to the design of the thing. But the machinery triggers an action. And it can look intelligent in various kinds of ways. Oh, look, it understands that the door is open, and that's why the little red light is on. That's not really intelligence. But supposing we had a machine that could play millions and millions and millions and millions of games of chess, and could be rewarded for winning the game and penalized for losing the game. Well, if you do that millions and millions and millions of times, the machinery might stumble onto a set of patterns and algorithms in the behavior, and through various extremely sophisticated mathematics and collations of patterns that the algorithms select other algorithms to be applied. It looks intelligent. It looks like it's doing something that a human couldn't do. And in fact, it can, because it's doing so in a different kind of way from the way human does it, the output, the achievement of the intention is similar to what a human would do, but not the way it was doing it. So we got to understand what's going on in there. I mean, the earliest computers were marketed as electronic brains. Well, that's a metaphor. It's not, they're not really brains. They don't work the way real brains do. Weirdly, these days, people are modeling the processing that brains do on the processing the computers do. There's some interplay between that. When Shazam and SoundHound came out, those two products, you know, amazing. I thought, well, so how does it work? Do they play a little fragment of sound to somebody who knows a million tunes? No. And in the earliest days, I suspect there weren't a whole lot of machine learning algorithms. There's a bunch of fast Fourier transforms and some incredible hashing and some database lookups and so on. It was all done lickety split. And it still seems miraculous to me, intelligent. But is that intelligence? But we wouldn't say it's an AI algorithm these days. Maybe they're using AI algorithms now, machine learning models of some kind. Maybe they're doing that. No. The catch is that the algorithm is not in our intentional design. It's not built that way. It is selected from a bunch of things that happen to match our intentions. And then we got software test automation tools that they're claimed to be AI driven. This has been going on for several years. Mabel was one of the first ones that came out. I don't think there was anything to do with a machine learning algorithm, and that was just a bunch of if statements or case statements back in that day. I don't know the basis of the claim by which a lot of these tools are making the claim of AI. But I suspect that there's not necessarily a whole bunch of machine learning models involved with them. If there are, I want to know how they're trained. This is very, very recent work. This is from something like a couple of hours ago. But in the ongoing discussions over our book and over how we might go about testing an AI product, here is some scribblings that we've got. There is an intention, and one of the things that we can do, remember the intention frame that I showed you before, one of the things we can do is we can question the intentions for the product and how it's going to get built and how customers are going to react to it and what the business wants from it. We can test that. Then there's a training process that goes into the machine learning algorithm. That's the mysterious black boxy thing that's at the center of all this. And that can be tested in the sense that we can look at the training data, we can examine the training data, and I'll be more explicit about those things in a bit. And we can do testing of that black box system by providing with some input and looking at the output and analyzing that and deciding how we feel about it. There's also a box around the central AI component that involves development and testing more or less as usual. The kind of testing that happens in the lower right corner of that diagram that I showed earlier in the discipline frame, and then testing that goes on in the realization frame when the AI has been embedded into a larger system. So one of the things we can take advantage of is the fact that while what's going on in here might be mysterious, we can analyze input and output from it, and we can analyze the components that might sort or filter or parse the stuff that's going in, or that might correct the stuff that's coming out. I don't know if you've looked at, I guess it's called Microsoft Copilot this week, built into Bing Chat. Or I noticed the same kind of thing happening the other day yesterday in ChatGPT. Those systems, if you're watching carefully, produce some output that is visible, and then sometimes it gets scribbled out and scribbled over, which I think is fascinating because that suggests to me that there is a filtering process that's happening after the original output from the large language model itself. Well, that sort of stuff can be caught as it comes out and examined and analyzed, and the algorithm that modifies the initial output and changes it into the later output, that can be analyzed too. that may involve itself a machine learning algorithm, but it may involve stuff that is more tractable and more visible and more controllable. So understanding the black box might help. There's a book I read. It's not a new book, but it still has some relevance, by a guy named Pedro Dominguez, if I remember correctly. It's called The Master Algorithm. In my recent reading, it's been superseded by this rather immense tome here, which I will momentarily stop sharing for a sec so you can see it. There's a book called Understanding Deep Learning by a guy named Simon Prince, and it is pretty amazing. It's just, look at this big thick thing, and I'm enthusiastically diving into it, and it's got lots of beautiful illustrations, and it's very mathy and a little bit intimidating to some degree, but nonetheless, I'm finding it to be a wonderful and super powerful reference to all the different kinds of things that are built into modern learning algorithms, and then this other stuff from Dominguez as well. So studying and understanding the domain that we're working in is essential. That puts a big burden on us as testers, but we're used to learning, aren't we? For LLMs in particular, let's see if we can understand what they actually do. A nice, fairly straightforward description of what's going on in an LLM is Stephen Wolfram's blog post, What is ChatGPT doing in software development, maybe even longer. Has a really nice article from the spring of last year, 2023, just calm down about GPT-4. Jessica Kerr wrote this really interesting thing, a developer's starting point for integrating with LLMs, lots of nice stuff about development work with LLMs and how testers can take a lot from that too. Chelsea Troy wrote a neat article called How Does AI Impact My Job as a Programmer? And then the classic paper from 2021, plus or minus a year, Emily Bender and Timnit Gebru and McMillan Major and Schmitchell, Margaret Mitchell, really her name is, the Stochastic Parrots paper. That's a really good one. This involves a lot of studying and a lot of work for testers, but as I say, we're kind of used to that. It's not magic. This stuff isn't magic, and it's important for us to recognize that it's not magic, but also to understand things about the way magic can sometimes work. Let me explain. Once upon a time, there was this horse. The horse's name was Clever Hans. Clever Hans had this incredible capacity to do mathematics. You'd ask, what's 3 plus 4? And Hans would go, clop, 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 clop with its foot and would stop at 7. You could ask Hans to do mathematics. In fact, oh, look, here's a bunch of problems that they put in front of Hans. And so they'd ask him, so what number do we need to put on the top and what number do we need to put on the bottom? And Hans would answer the question. Well, it turns out, this is a guy named Willem van Olsten, if I remember correctly. It turns out that when they looked more carefully, Hans, being a horse and horses being very attuned to human reactions, would watch the audience, would watch the crowd or would watch Van Olsten, and what would happen? 5, 6, 7, and the horse would stop based on the reaction of the humans who were observing the horse in action. So Hans wasn't really doing mathematics. Hans was responding to human cues. because horses, like dogs, are very perceptive, very highly attuned to what humans do. So an important thing when you're evaluating an LLM as a civilian, but even more importantly as a tester, is to recognize the role that you play in it. Before we go to the next slide, by the way, here's what Office 365 offered in as I was building this presentation. Here's what it offered as a caption for this image. A person standing next to a horse. Don't know about you, but I see two people. So this isn't wrong, but you look at this, if you're like me, you say, well, that's not right. If you are a more credulous person, you would say, well, that is right. I mean, technically there is a person standing next to a horse, but as a tester, I'm all about how stuff is wrong and how that might present risk to people. So the role of repair in how LLMs work is super, super important. LLMs are like fortune tellers or tarot card readers or like drunks in bars. Maybe some of you have had the experience of sitting next to somebody, a complete stranger at a bar, and saying something like, all right, he says, so what are you doing here? And I say something like, well, I'm on a 2-week business trip. I'm here teaching. He says, do you like that sort of stuff? And I say, well, yeah, it's great. I mean, I'm away from my wife. And the drunk says, you know what? You should get flowers for your wife. When you get off the airplane, if there's a flower stand at the airport, go get some flowers for your wife. And I think, wow, that's insightful. That's a great idea. I should do that. But that's me. He doesn't know anything about me. He doesn't know about my relationship with my wife. He doesn't know, maybe, and it's not true of my wife. My wife loves flowers, but maybe she doesn't care so much about flowers. Maybe she'd prefer a nice bottle of wine. But the point is that I'm repairing what the drunk is doing. And I'm giving too much credit to the drunk and not enough credit to my own knowledge and wisdom and so on and so forth. And I worry about that because I see people these days saying stuff like, oh, the LLM does a much better job than what I could do. Well, if you looked a little bit more closely, you would find actually you're quite a bit brighter than the LLM. What's happening is that it's synthesizing a whole bunch of stuff based on patterns in its training data. And it's saying to you stuff that a drunk at a bar would say, because it's always nice to buy your wife flowers, isn't it? So learn about the role that people play. Notice that when the LLM gets something right, you remember that. It's just like a cold reader, a tarot card reader, a fortune teller. When they get something right, you remember it. Yay. But when it gets it wrong, you don't pay very much attention and you say, yeah, whatever. So several references to help you notice the role of repair and what large language models actually do. There's a book, there's a copy behind me on the shelf called The Shape of Actions by Harry Collins and Martin Cush. I am mad at this guy, Baldur Bjarnason. I'm mad at him because he did something that I would have done if I'd been more energetic and earlier and a little bit less lazy. He wrote a fantastic article called The LL Mentalist Effect, the Large Language Mentalist Effect, how chat-based large language models replicate the mechanisms of a psychic's con, how it replicates cold reading. Because when it gets it right, you remember it. And when it gets it wrong, you don't. And there are lots of patterns in its output that help get things right. Another great book on the subject of cold reading, Ian Rowland. Another book by Harry Collins called Tacit and Explicit Knowledge, and yet another one called Artificial Intelligence. Use tools. If you want to use an LLM to help you generate test ideas, go ahead. Go ahead. If you want to use an LLM to help you review the test ideas you got, go ahead. But recognize that it's not magic. It's not more intelligent. It's giving you stuff that has been pulled down off the web and converted into text that looks in some sense naturalistic because it follows patterns of text on a probabilistic kind of basis. Another thing that's worth looking at is the data. The training for any machine learning model is like millions of examples of that game, Bring Me a Rock. So what happens is you go to this is how essentially how supervised learning or reinforcement learning from human feedback works. The machine goes out and it comes back with an algorithm that produces some kind of output, and then you provide with feedback that causes it to revise its weightings and so on and so forth. Well, when you're dealing with unsupervised learning or other kinds of patterns like that, when you're dealing with text generation, it's important for the training data to be relevant to the population that it's addressed to. So where does that training come from? How was it sampled? Where did it come from? When did it come? Does it represent what we think it's represent? What we think it's represent? What are the biases that are intrinsically built into it? I started by saying, does the data model the world as it is? But the data that is being used to train an LLM is relative to the output of the model past. It's not current. It's not up to date. So lots of other questions to ask about that. This is where we're looking at the testing part. If we look back at this diagram here, this here, that's what we're doing. Okay, 2 minutes left. Oh my goodness. Okay, so what can I do to make this go a little bit quicker? Let's look at this. Does anybody know how the thing works? How well do they know? Do we have reason to believe that the product is consistent across all the relevant input? In order to do that, we got to do repeated experiments. Don't just settle for the first instance of correct behavior. Try again. Try asking the LLM, are you sure? And see if it changes its answer, because a lot of the time it will. Now, it might be okay. Once again, if the human is in sufficient control of the output and what's done with it. One of the tasks that we got to perform here from a testing perspective is to develop and apply risk models. Now, there's a bunch of these here. You can take a screenshot of it if you like. But what I encourage testers to do is to develop their own risk models. You can base it on other stuff. We did this. James and I did this. Whoops. Geez, where am I? Oh, I accidentally clicked on the link. We observed specific patterns of misbehavior in large language models that tended to be undesirable or risky. And we started compiling them as we were observing them. So let me give you an instance of what they look like. When you are interacting with an LLM to test it, look for these patterns. Most of the time, the LLM will not ask framing questions. If you show concern about the answer, it will change its answer. It may invent facts. It may reveal information that it shouldn't. It may not provide output in a way that is consistent with our framed intentions. There's a possibility, this is a particular problem in earlier versions of chatbots, that they provided racist, sexist, misogynist answers. It may appear overconfident. It may provide incorrect answers. It keeps changing its output. It may not remember its earlier output. Larger token windows can help with that. It may repeat the same information over and over again and be more explicit or more prolix than we want it to be, it doesn't necessarily do what it says that you should do. You notice that in one of my first hurdle tests earlier on. It may not give a complete answer to the question it would ask. Of course, it doesn't tell you how it came up with its answer because it doesn't know and it can't do that. It can't be refined in certain kinds of ways. It's certainly vulnerable to that. It may not provide the answer it was asked, and it might provide a whole bunch of stuff that's not particularly useful. So those are some of the ways that we could do this. Let me finish with this one, though. Bring to the testing job, bring to the work of testing radical skepticism. Don't treat a pleasing result in a demonstration or in an experiment that you do as evidence of reliability or good behavior. Remind yourself to say these things. Did it give a fully correct answer? Was the answer that it brought cherry-picked from a set of answers, especially when you're looking at a demo? Look into how much of the answer we fed to the bot beforehand and whether the answer we got is consistent with the answer we fed in. That's the problem with retrieval augmented generation. Sometimes it pays attention to it and sometimes it doesn't. How much are we steering the bot into giving us an answer that we want? Is it trustworthy to do it again? And finally, we get this a lot from some of the enthusiastic fanboys. When we see a failure, are they reframing that as limited success? Got to be careful of that. As testers, we've got to be on our guard. We've got to be the skeptics. We've got to be the ones who are focused on problems because nobody else in the project is like that. We are unique in that sense. As testers, our focus is on trouble. So that's my advice. Focus on trouble.
Thank you, Michael, for that engaging talk. And before we conclude, I would like to remind everyone to register for Quality Next Latin America edition that is coming up in September. Please click on the link in the chat to register and secure your spot. Hope to see you at Quality Next in September.
With that, we've reached the end of QuaNTA NXT 2024. A heartfelt thanks to all our incredible speakers. Your contributions have made this event truly exceptional. And a big thank you to all those who tuned in today. We hope you found the sessions as inspiring and thought-provoking as we did. As we wrap up, we encourage you to stay connected as we look forward to seeing you at the next event. Until then, stay curious and keep innovating. Thank you and have a wonderful day.